When you die, you don't step outside the universe, because there is no outside to reach. The cosmos isn't a room you sit inside, it's the fabric that builds every part of you. Your atoms, your thoughts, your memories, all of them are temporary patterns carved into this single endless structure. And the moment that pattern fails, nothing leaves the universe, because nothing ever could. You don't exit reality. You simply stop holding the shape you once had. But if there's no outside, what really happens to you when everything that makes you stops working? Do you fade into nothing or dissolve back into something larger? Before we go deeper, leave a like if you've ever wondered what actually happens to you after death. And tell me in one word, escape or remain. I want to see how you picture it. We grow up surrounded by the language of escape, leaving this world, leaving Earth, leaving the galaxy, leaving our bodies behind. Hidden inside all of that is a quiet picture most people never question. The idea that existence is a room, that the universe is a kind of building, and that somewhere beyond its walls there is a hallway you might one day walk into. Physics has spent the last century quietly tearing that picture apart. The universe, as modern cosmology understands it, is not an object sitting in a bigger space. It is the space. It is the fabric in which locations, times, and events even make sense. Asking what lies outside the universe is a bit like asking what lies north of the North Pole. It sounds like a sensible question in everyday language, but the more precisely you define your terms, the less it means. Right now, as you listen, a human life is unfolding in a tiny patch of that fabric. Your heart burns chemical fuel and pushes blood through narrow vessels. Your brain shuffles charges across intricate networks of cells, creating thoughts, memories, fears, and hopes. Out of that shifting electrical storm comes something almost absurd, a pattern of matter that can ask whether it will ever escape the very reality it's made from. That is the first strange truth to hold on to. You're not a passenger sitting inside the universe like someone riding in a car. You're built from it, down to the last proton and electron. There is no extra ingredient, no secret substance smuggled in from somewhere else. Whatever you are, body, brain, mind, experience, is a particular way for the universe to arrange itself for a short time. And yet, the fear persists. What happens when this pattern breaks down? When the heart stops? When the brain goes dark? When the story you tell yourself about yourself suddenly cuts off? Do you fall into an absolute nothing? Do you move to some other dimension? Does a door open at the moment of death that was invisible a second before? Different cultures answer that question in different ways. Heavens above, underworlds below, reincarnation, digital afterlives, simulations. The details change, but the structure is the same. There is this reality, with its matter and energy and physics, and then there is somewhere else, some other layer, where the rules are different and you might continue. Our best physical theories so far refuse to give that somewhere else a place to exist. Space and time are not a stage sitting in a larger theatre. They are the stage itself. The rules of physics describe how things move and interact inside that stage, but they do not point to a larger arena beyond it where you could step once you're done here. If anything like that exists, it leaves no trace in the equations used to describe stars, atoms, and everything in between. At first, that can sound like a cosmic prison. No exit, no escape, not even in death. But that image is misleading. A prison is a room you are trapped in, separate from what you really are, with a world outside you wish you could return to. The universe is not that room. The universe is the reason you can exist at all. Every particle in your body, every photon that hits your eye, every chemical reaction that keeps you alive is part of the same ongoing process. Before asking where you might go after you die, it helps to ask a simpler question. Where did you come from, at the level of raw material? Not your childhood home or your parents, but the atoms themselves. The iron in your blood, the calcium in your bones, the carbon in your cells. None of that was made on Earth. Those atoms were forged in stars, in nuclear furnaces so hot and dense that simple elements were crushed together into heavier ones, then scattered through space when those stars died. Long before Earth existed as a planet, long before there were creatures with eyes or brains or language, the universe had already prepared the ingredients that would eventually become you. Hydrogen atoms in your body trace their history back to the first minutes after the Big Bang. Heavier elements were assembled in multiple generations of stars that lived and died over billions of years. Your body is not a new object that appeared from nowhere. It is a temporary arrangement of incredibly old pieces. Every breath you take pulls in oxygen that once sat locked in rocks, or floated in the lungs of other animals, or drifted in the air above ancient forests. Every sip of water contains hydrogen that has been part of stars, comets, clouds, and oceans across cosmic time. The atoms that currently spell you have moved through countless roles — soil, air, plants, other living things — before adopting this one for a few decades. This leads to a quiet but important conclusion. You do not truly own your atoms, you are borrowing them. The universe lends you this particular pattern for a while, this body, this brain, this mind, and then, inevitably, the pattern fails. Not because the universe is hostile, but because complex structures in a universe with time and entropy eventually break down. When that happens, the pieces do not vanish. They go back into circulation. The usual way people frame the question is, where will I go when I die? That phrasing assumes there is a you separate from the physical pattern, a passenger who might be moved to a different vehicle, a different world, once this one stops working. Physics pushes a different question into view. In a universe where nothing comes in from outside and nothing can leave, what does it really mean for a pattern like you to end? In what sense does it continue, even when the version you recognize is gone? Some people find comfort in religious stories. Others find comfort in the idea of complete oblivion, a clean, sharp end. Both draw a simple line between existence and non-existence, but the actual universe appears messier and stranger. Matter and energy do not leave the game, they just keep moving into new forms. Even the information about how they were once arranged, including the fact that you were once here, in this shape, may be more deeply woven into reality than intuition suggests. This journey is about following that thread, from the star-forged atoms that became your body, through the life you know, to the moment your brain can no longer sustain the pattern you call me, and then far beyond into the deep future of the cosmos. Along the way, you will see why there is no outside to escape to, and why the fact that you never leave the universe is not a story of confinement, but a story of connection. To understand just how inescapably tied you are to everything around you, not poetically, but physically, atom by atom. The next step is to go back before Earth, before life, before you, into the violent hearts of the stars that built the ingredients of your body in the first place. Every part of you is older than you are, and some parts are almost as old as the universe itself. Yet they have no memory of where they have been. They simply keep flowing through new shapes, stars, planets, oceans, bodies, as if reality were endlessly rearranging the same small set of pieces into new stories. Look up at the night sky and imagine not a pretty backdrop, but a factory floor. For most of human history, those points of light were mysterious fires, distant and unreachable. Then physics slowly revealed something far stranger. Those fires are not just shining, they are building. Inside them, the raw ingredients of you are being forged. A star begins as a cloud of gas and dust, mostly hydrogen, collapsing under its own gravity. As the gas falls inward, the core heats up, atoms move faster, collisions become more violent. At roughly 15 million degrees, hydrogen nuclei begin slamming together so hard they fuse into helium. 4 hydrogen nuclei become one helium nucleus, and a tiny bit of mass is shaved off and turned into energy. That energy pushes outward and balances gravity pulling inward. That quiet tug of war, gravity compressing, fusion pushing back, is why stars shine and do not simply collapse. For a long time, that is all a typical star does. It slowly fuses hydrogen into helium, radiating light and heat. But the most massive stars, far heavier than our Sun, burn through their fuel quickly and live fast, violent lives. When the hydrogen in their cores runs low, gravity gains the upper hand for a moment. The core contracts and heats up even more until helium itself begins to fuse, forming heavier elements, carbon, oxygen, neon, silicon, in layers, like shells inside the star. Each stage of fusion builds heavier nuclei and releases energy that again fights gravity. As long as the star can find something new to fuse and still get energy out of the reaction, it can hold itself up. But there is a hard limit. When the core fills with iron, the rules change. Fusing iron does not release energy, it consumes it. At that point, fusion can no longer pay gravity's bill. The balance breaks. In a fraction of a second, the core collapses. The outer layers crash inward, hit the stiffening core and rebound. A shockwave races outward. The star tears itself apart in a supernova. For a few days, a single star can outshine an entire galaxy. Temperatures and pressures spike to extremes, and in that short window of chaos, the universe does some of its most important work. Elements heavier than iron, like gold, iodine, uranium, are forged in frantic, rapid reactions and flung into space. The iron in your blood, the same iron that lets red blood cells carry oxygen, was created in such a star's core and released when it died. The calcium in your bones, the oxygen you breathe, the carbon that forms the backbone of your DNA and proteins, all of these were manufactured in stars that lived and exploded long before Earth existed. "You're made of stardust" is not poetic exaggeration. It is a straightforward statement of astrophysics. After a supernova, the remains of the star do not disappear into some outside realm. They spread into vast cold clouds between stars. These clouds are mixtures of hydrogen, helium, and heavier elements from multiple stellar generations. They drift for millions of years, shaped by gravity, shock waves from other supernovae, and the motion of the galaxy itself. Gravity never turns off, even when it is weak. Tiny overdensities pull in more material. Clumps grow. As they grow, their gravity strengthens, pulling in even more. Over tens of millions of years, a patch of this gas can collapse into a new star surrounded by a flat, spinning disk of leftover material. Our Sun formed in such a nursery about 4.6 billion years ago. The disk around it, dust, ice, metal-rich grains, began to collide and stick together. Dust became pebbles, pebbles became boulders, boulders became kilometre-sized bodies, and eventually some of those bodies grew large enough to become planets. None of this process tries to make life. It is just gravity, motion, collisions, and the laws of physics playing out. Yet out of that blind dance, a rocky planet emerged at just the right distance from its star for liquid water to exist on its surface, with a mix of elements that would later prove chemically fertile. That planet was Earth. Early Earth was not a blue marble with clouds and continents. It was a molten, hostile world, hammered by impacts, its surface an ocean of magma slowly cooling. Volcanic eruptions released gases to form an atmosphere. Water condensed and pooled into oceans. In that changing environment, chemistry had room to explore possibilities. Simple molecules formed, broke apart, and recombined, powered by sunlight, lightning, geothermal heat, and chemical gradients at the bottom of the sea. At some point, the details are still debated and experiments are ongoing, some of those molecules began to do something critical. They started to copy themselves. Not perfectly, but well enough that variations could matter. Once you have self-replicating structures that occasionally make imperfect copies, you have the raw material for evolution. Over immense spans of time, that process produced cells, then more complex cells, then multicellular organisms, tissues, organs, nervous systems, and eventually brains capable of modelling the world around them. In one small branch of this vast evolutionary tree, a particular kind of brain appeared. It could remember, plan, tell stories, fear its own ending, and look up at the stars wondering what they were. That brain is built from atoms forged billions of years earlier in stars that never once suspected that their remains would one day become curious primates on a small, rocky world. When you look at your hand, you are seeing a structure that has existed in its current form for a few decades. The atoms that make it up, though, have histories stretching back billions of years. Hydrogen atoms in your water trace back to roughly 13.8 billion years ago, to the hot early universe shortly after the Big Bang. Heavier atoms like carbon, nitrogen, and oxygen come from multiple generations of stars that were born and died before our Sun even formed. Those atoms have been many things. Before they were in you, they likely spent time locked in rocks, dissolved in oceans, drifting in the atmosphere, or incorporated into other living organisms. When you breathe in, some oxygen molecules entering your lungs were once part of the air dinosaurs inhaled. When you drink a glass of water, some of its molecules pass through ancient rivers and ice caps, and perhaps the cells of long-extinct plants and animals. At no point in this entire chain did any of this matter leave the universe or come in from elsewhere. The hydrogen formed in the early universe, the stars that fused heavier elements, the supernovae that exploded, the gas clouds that collapsed, the planet that formed, the chemistry that woke up and started copying itself, all of it took place within one continuous physical reality. There was no external warehouse where atoms waited before being assigned roles. There was no outside realm they visited between one form and another. You are a late chapter in a very long physical story. The universe has been shuffling and reshuffling the same basic ingredients for billions of years. Your particular arrangement, your body, your brain, your mind, is just one of those arrangements, incredibly intricate and short-lived. When it ends, the pieces do not go somewhere beyond the universe. They remain in play, ready to participate in new patterns you will never see. This is the first concrete way in which you cannot escape the universe. You never arrive from outside, and there is nowhere outside for your atoms to return to. Everything that makes you possible has always belonged to the universe, and will continue to belong to it after you're gone. But you might still be tempted to think, fine, my atoms stay here, but what about me? Could I or my descendants at least travel to the universe's edge, to some boundary where it ends and something else begins? To see why that idea also falls apart, you have to rethink what kind of thing the universe is. Not an object floating in a larger void, but the very fabric of space and time itself, with no edge to reach and no outside to escape into. Imagine standing in an endless forest and trying to walk to the edge of trees. No matter how far you go, there are more trunks, more branches, more shadows stretching between them. At some point you realize the problem is not your legs, it's the way the forest itself is arranged. You're not approaching an edge because there is no edge to approach. Most people, even without noticing it, imagine the universe like a giant sphere sitting in a bigger empty space. Inside the sphere is everything. Galaxies, stars, planets, you. Outside the sphere is nothing, a pure empty void. In that picture, it feels natural to ask, could we travel to the edge of the sphere? Could we one day stick a hand through and feel what's outside? Modern cosmology says that picture is wrong at the root. The universe is not a ball of stuff floating in a larger container. It is the container. Space is not something the universe sits in. Space is part of what the universe is. Asking what lies outside the universe is like asking what lies outside all of space and all of time. There is no direction to point in, no coordinate to move toward, because outside is a concept defined inside the thing you're trying to step outside of. A simple analogy helps. Think about the surface of Earth. Not the whole planet, just its two-dimensional surface, the skin. From the ground, it feels flat and endless, but in reality it is finite and curved. You can start walking east and keep going forever, circling the globe again and again, and you will never encounter a sharp edge where the surface stops and empty nothing begins. The Earth's surface is finite, but it has no boundary. Our observable universe might be like that, but in 3 dimensions instead of 2. Space could be curved or flat, infinite or finite, but in all the realistic models there is no physical wall where the universe ends. You can keep going in any direction, and you just get more universe, more galaxies, more dark matter, more empty space between. The key idea is that space itself can be curved or stretched without needing an outside for it to curve into. When cosmologists say the universe is expanding, they do not mean galaxies are flying outward into a pre-existing emptiness. They mean the distances between galaxies are growing because the fabric of space is stretching. New space appears between things, not at some outer border. Imagine drawing a bunch of dots on a balloon and then inflating it. As the balloon expands, every dot sees all the others moving away. There is no special center on the surface. From any dot's point of view, it looks like everything is receding. If you live on the surface, you can talk about distances between dots growing, but you cannot step off the surface and watch from outside. That outside is not part of your world. In this analogy, the balloon's surface is like our 3-dimensional space. The expansion is the increase in distance between galaxies over time. We often visualize the balloon in a room, expanding into the surrounding air, but that is just a crutch for our 3-dimensional brains. The surface itself does not require the room to exist. The math that describes its curvature and expansion works entirely within the surface. The universe appears to work the same way. When telescopes look at distant galaxies, they see light stretched to longer, redder wavelengths, evidence that space between us and those galaxies has expanded while the light was travelling. The farther away a galaxy is, the faster it seems to recede, not because it is rushing through space like a rocket, but because more space is being added between us and it. In this picture, what would it even mean to escape the universe? You can launch a rocket. You can leave Earth, leave the solar system, even leave our galaxy over unimaginable timescales. But every step of that journey is still a path through the same space-time fabric. There is no coordinate you can aim for that takes you beyond space itself. Movement is always movement within the universe, never beyond it. You might try to salvage the old image by saying, fine, maybe we can't reach the outside physically, but it still exists. The problem is that all the evidence gathered so far and the equations that describe cosmic expansion, gravity and light, never need that outside. They work perfectly well without it. Physics is ruthless about unnecessary concepts. If something has no observable consequences, the universe behaves as if it is not there. This has a direct consequence for the idea of escaping after death. Any where you could go, any place with coordinates, distances, durations change, would itself be part of a spacetime, part of a universe. To say you leave this universe to go somewhere else is to imagine another stage with its own rules. But from the perspective of physics, that would just mean a bigger universe with more structure, not a true outside where existence itself has been left behind. Even the notion of void in physics does not rescue the idea of escape. The vacuum of space is not absolute nothing. It has fields, quantum fluctuations, a structure that can bend and ripple. Empty space can expand, curve around mass, and give birth to particles in the right conditions. It is part of reality's machinery, not a separate realm you enter when you're done being matter. So when you think about leaving Earth, leaving the galaxy, leaving existence, you're still using the wrong map. There is no edge of space you can sail past. There is no beyond of spacetime that you can fall into. There is only the fabric itself with different regions, different states, different futures, all of them inside the same overarching reality. You can move to a different position within that reality. Your atoms can be rearranged into new patterns. The universe can expand, cool, and change character. But at no point is there an exit door labelled outside. To step through such a door would require stepping out of distance, out of time, out of causality, concepts that do not even have meaning once the universe that defines them is gone. This is why, in a precise physical sense, there is nowhere to escape to. Not in a starship, not as a soul floating in some parallel realm, not as particles dissolving into a perfect empty void. Everywhere you could possibly go in life or in death is just another part of the same underlying reality, described by some version of the same fundamental rules. Realizing that removes one fantasy, but it sets up a deeper question. If you can never get outside space and time, and if even your atoms are permanently trapped within this cosmic fabric, what actually happens to you when the pattern that feels like you breaks down? That is where the physics of death itself enters the story, not as a mystical border crossing, but as a physical event, unfolding atom by atom and second by second, entirely within the universe you can never leave. If you want to escape something, the first instinct is simple. Just go far enough away from it. Leave your town, your country, your planet, your star, your galaxy. Put enough distance between you and the thing you're trying to outrun, and eventually it should disappear in the rearview mirror. In everyday life, distance and escape feel almost the same. That intuition collapses the moment you try to apply it to the universe itself. You can leave Earth. You can, in principle, leave the solar system. Given extreme timescales, you could even drift away from the Milky Way. But at every step, the same strange fact holds. No matter how far you go, you're never closer to some cosmic edge, because distance inside the universe is not a path toward a boundary. It is just movement within the endless middle. Start small. Imagine the first big leap, leaving Earth. From down here, space feels like out there, a place you could go to be away from all this. Astronauts do it. They climb into a rocket, ride a controlled explosion up through the atmosphere, and watch the planet shrink into a glowing sphere beneath them. The view is transformative, but physically, nothing magical has happened. They are still deep inside the same gravitational well of the sun, still in the same space-time, still obeying the exact same physics. Push farther. The solar system itself has a kind of soft border, marked by where the sun's influence fades into the surrounding galactic environment. In 2012, Voyager 1 crossed a region called the heliopause, the place where the solar wind gives way to the thin gas between the stars. Headlines called it our first emissary to interstellar space. That sounds like an edge, a frontier crossed. In reality, Voyager did not pass through a wall. It simply moved from one kind of space into another, the way a ship leaves a river and enters the sea. From Voyager's new vantage point, the sun is just another star among many. But that outside it now drifts through is still part of the Milky Way. The galaxy is a vast disk of hundreds of billions of stars, about 100,000 light-years across. To cross it from one side to the other, even at a significant fraction of light speed, would take longer than human civilization has existed. Yet even if some unimaginable future ship managed it, what would be on the other side? More galaxy, just a thinner stretch of stars as you move toward the galactic halo. Beyond that, intergalactic space, which sounds like it should be a kind of cosmic wilderness, empty and pure. But it is not truly empty. Thin gas, dark matter, stray stars, rogue planets, and the faint glow of distant galaxies fill even those regions. You have left one structure, but you have not left the universe. You have only changed neighborhoods. Imagine you had a ship that could cruise at a decent fraction of a light speed, and a civilization willing to wait hundreds of millions or billions of years. You set a course straight out, away from the Milky Way, and keep going. For a long time, the galaxy behind you would still dominate the sky, a bright, spinning disk shrinking into a distant smear of light. As you crossed the gulf between galaxies, the space around you would look darker, but not fundamentally different. You would still measure the same physical constants, still see the cosmic microwave background glowing faintly in all directions, still be surrounded by space-time obeying the same rules. Eventually you might approach another galaxy, a cluster, a filament in the cosmic web. The large-scale structure of the universe where galaxies form threads and nodes like a three-dimensional spiderweb of matter. From that new vantage point, the Milky Way would be just one faint dot among many. But again, nothing about your journey would have brought you closer to an edge. You would always be travelling within the same interconnected network of matter and space. The observable universe, the part we can see, has a kind of horizon. Light has a finite speed, and the universe has a finite age, so there are regions whose light has not had time to reach us yet. That defines a sphere around us, about 46 billion light-years in radius, inside which we can, in principle, receive information. It is tempting to confuse that horizon with an edge. It isn't. It is not a wall in space, it is a limit in time. Beyond it, the light has simply not arrived yet. If you were to travel far in one direction, your observable universe would change. New regions would come into view, others would slip over your personal horizon. The map of the cosmos available to you would be different than the one available from Earth, but at no point would you find a place where galaxies simply stop and are replaced by literal nothing. In every direction, for as far as we can tell, there is more universe. This is where intuition, shaped by daily experience on a finite planet with edges and borders, starts to fail. On Earth, going far enough in one direction will eventually deliver you to a coast, a fence, a wall, or at least a place where the landscape clearly changes. Cosmology points to a kind of reality where you can keep going forever and remain permanently inside, because inside and outside stop being meaningful distinctions at the scale of everything. Even the ultimate expansion of the universe does not rescue the idea of escape by distance. Observations suggest that not only is space expanding, but that this expansion is accelerating, driven by something called dark energy. Over extremely long timescales, more and more galaxies will cross our cosmic horizon, not because we are moving, but because space between us and them is stretching so fast that their light can no longer reach us. They will fade, redshifted into invisibility. It might feel as if they have gone somewhere else. They haven't. They have simply become causally disconnected from us. Still out there, still part of the universe, but forever unreachable. You can think of this like being in a small boat on a lake that is rapidly freezing from the edges inward. You can row in any direction you like, but the ice forms so quickly that regions of water you could once have reached are now sealed off forever. They still exist as part of the lake, but they are no longer part of your possible future. The universe appears to be doing something similar on a cosmic scale, not creating an edge, but creating regions that can never again influence each other. All of this leads to a simple but uncomfortable point. Distance is not a ladder you can climb to escape the universe. It only lets you rearrange your position within it, and as the universe expands, it can actually trap you in a smaller and smaller pocket of what is ultimately there. You can put as many light years as you like between yourself and your starting point, but you will always be moving through the same underlying reality, under the same overarching set of rules. So if you cannot escape by going far, and there is no edge to reach, and even the accelerating expansion of space only isolates regions rather than ending them, then running away through space will not free you from the universe. That leaves another angle people reach for, sometimes without realizing it. If you cannot outrun the universe in space, maybe you can outrun it in time. Maybe death is not just a change of location, but a way to step out of the story altogether. To see why that too fails in a very specific and revealing way, you have to watch, in close detail, what actually happens when a human body stops, and how every part of that event is still fully contained within the universe that never lets anything truly leave. To understand why you can never escape the universe, even in principle, you have to face one of its most stubborn rules. There is a speed limit written into the structure of reality itself. It is not a suggestion or a technological hurdle we might someday overcome. It is baked into how space and time behave. That limit is the speed of light in a vacuum. In everyday life, speed feels like a question of engineering. Build a stronger engine, a lighter vehicle, a smoother road, and you can go faster. Humans went from horses to steam trains to jets to rockets by doing exactly that. It is tempting to imagine that with enough innovation, the same logic will carry us to near infinite speeds, maybe even beyond the stars in a single lifetime. The universe does not cooperate with that fantasy. According to Einstein's theory of special relativity, the speed of light is not just fast, it is the maximum speed at which cause and effect can travel. Nothing with mass can be accelerated to or beyond that speed. As an object moves faster and faster, something strange happens in the math and in reality. Its kinetic energy increases, and with it, its relativistic mass, a way of saying that it becomes harder and harder to push. Each additional bit of speed costs more energy than the last. If you imagine trying to accelerate a spacecraft with mass all the way to light speed, the required energy grows without bound. In the limit, you would need infinite energy to reach the speed of light, infinite fuel, infinite time, infinite everything. That is the universe's way of saying, no, this is not a technical problem, this is a structural one. The light-speed barrier is not like a wall you might break through. It is like the horizon of a curve that you can approach forever without ever touching. On top of that, as you approach this limit, time itself starts to behave differently. From your perspective on board the ship, time ticks along normally, but from the perspective of someone watching you from back home, your onboard clocks slow down. Your heartbeat, your thoughts, your entire life appear to run in slow motion. This effect is not an illusion. It has been measured in particle accelerators and with precise clocks on fast-moving satellites. This time, dilation creates a bizarre situation. If you could travel at a speed extremely close to the speed of light, you might cross vast cosmic distances within your own lifetime, a few decades of subjective experience. But back home, thousands or millions of years could pass. For you, the journey is short. For the rest of the universe, it is long. High speed does not let you escape the cosmos. It lets you jump forward in its timeline. This is the deeper reason the speed limit matters for the idea of escape. You can never outrun light, and light is how information moves. Any event that could possibly affect you in the future must send a signal that reaches you at or below light speed. Anything that has not had time to send such a signal lies outside your light cone, a region of space-time that is fundamentally inaccessible to you, not because there is a wall, but because there is not enough time for interaction. General relativity extends this idea and ties it to gravity and the shape of space-time. Massive objects curve space-time. Light follows those curves. Clocks tick at different rates in different gravitational fields. Everything you do, every motion, every signal, every choice, is constrained to move within the geometry set by matter and energy. There is no way to step outside that geometry, because it is not a background you are placed into. It is the structure that defines what motion even means. When you hear that nothing can move faster than light, it is easy to picture objects as cars on a highway with a speed sign, but the reality is stranger. The speed of a light is the same for all observers, no matter how fast they are moving. To make that possible, the universe adjusts space and time themselves. Distances contract, durations stretch, so that no measurement of cause and effect ever requires faster-than-light communication. The limit is not just a rule about speed. It is a rule about what kinds of stories reality is allowed to tell. Some speculative ideas, warp drives, wormholes, shortcuts through higher dimensions, pop up in science fiction and sometimes in serious theoretical papers. They play with the geometry of space-time to try to cheat the speed limit. Even when the math allows such structures in principle, they almost always require exotic conditions, negative energy densities, perfect stability, exact configurations. that no known process in the real universe can provide. And even if a wormhole or a warp bubble did exist, it would still live inside spacetime, subject to its overarching rules. It would be a strange path within the universe, not a door out of it. The speed limit also interacts with cosmic expansion in a crucial way. When we say distant galaxies are receding from us faster than light, we're not saying they are breaking the rules. The galaxies are mostly sitting still in their local space. It is the space between us and them that is stretching, over large enough distances that stretching accumulates so quickly that light emitted now from those galaxies will never reach us. They are not outside the universe. They are simply outside our ability to ever exchange information with them. From your point of view, that creates a shrinking bubble of potential interaction. As time passes and expansion accelerates, more and more of the universe drifts beyond your causal reach. You cannot send signals there. You cannot receive signals from there. You cannot travel there, no matter how fast your ship is, because getting there would require outrunning the expansion of space itself, and, with it, the propagation of light. The speed limit and the expanding fabric work together to fence off parts of the universe forever, not as a border you could touch, but as a horizon you can never cross. This is not just an abstract curiosity. It has direct implications for the idea of even a hypothetical ultimate escape. Any path you could take must be a path through space-time. Any influence you could exert or experience must flow within light cones defined by that structure. There is no choice, no motion, no signal that can jump outside that network of constraints. The universe is not just where things are, it is how they can possibly change. So even in the wildest future you can imagine, civilizations spanning galaxies, ships traveling at relativistic speeds, engineering projects that move stars, every action would still be bound by this limit. No one outruns light. No one sends a message into a region of reality that is truly beyond the reach of physics. You can disappear from one another's horizons. You can become forever disconnected pockets of existence. But you do not step into a realm where the universe and its rules no longer apply. If escaping by distance fails, and escaping by breaking the speed limit is impossible, it might feel as though the only real way out is to stop participating altogether, to let your body fail and your consciousness end, and hope that death is a kind of exit ramp from the whole system. To see why that is not what physics describes, you have to zoom in on death itself, not as a philosophical event, but as a chain of physical processes playing out inside a body that has always been, and will always remain, part of the same inescapable universe. Death feels like a border. One moment there is a person, breathing, speaking, remembering, wanting, and the next, there is a body that does none of those things. From the inside, it is easy to imagine that something has left, slipped away, stepped through a door you cannot see. From the outside, physics tells a colder, simpler story. Nothing leaves the universe, but a very specific pattern stops working. Start with the organ that keeps everything else going, the heart. As long as it beats, it pushes oxygen-rich blood through a network of vessels, delivering fuel and removing waste from trillions of cells. Those cells use oxygen to burn sugars and fats, releasing energy in controlled steps. That energy powers everything you do, from flexing a finger to recalling a childhood memory. When the heart fails, whether from electrical chaos, blockage, trauma, or exhaustion, that steady flow stops. Within seconds, blood pressure collapses. Cells in your brain are among the first to feel it. They are greedy and fragile, with almost no energy reserves. They rely on a constant supply of oxygen and glucose to keep their ion pumps running, tiny molecular machines that maintain the difference in charge between the inside and outside of each neuron. That difference is what allows neural signals to fire. Without oxygen, the pumps slow, then fail. As the pumps shut down, the electrical balance across neuronal membranes collapses. Ions rush where they are not supposed to be. Neurons fire in uncontrolled bursts, then fall silent. Within about 10 seconds of complete blood loss to the brain, consciousness fades. You do not experience the rest because the system that produces experience is already gone. From the outside, however, things are only beginning. Over the next few minutes, cells begin to accumulate damage from lack of energy. Without working ion pumps, calcium floods into neurons, triggering destructive chemical reactions. Enzymes that are usually tightly regulated start breaking down proteins and membranes. Reactive molecules called free radicals build up, damaging DNA and other structures. Brain cells that are deprived of oxygen for long enough pass a point of no return. Even if circulation is restored, they will not recover. Elsewhere in the body, similar processes unfold on slightly longer timescales. Muscle cells, liver cells, kidney cells, all of them depend on oxygen to keep their internal chemistry in a balanced state. Cut off that supply, and they switch to emergency, low-efficiency pathways that quickly generate acid and toxic byproducts. The environment inside each cell becomes hostile. Membranes weaken, organelles burst. Over minutes to hours, more and more cells die. At the level of the whole organism, death is not a single instant but a transition. Different systems fail at different rates. Clinical death, when heartbeat and breathing stop, can sometimes be reversed if circulation is restored quickly enough. Biological death is when enough critical cells, especially in the brainstem and cortex, have been irreversibly damaged. There is no longer a functioning pattern capable of generating awareness, memory, or identity. The body may still have islands of living tissue, but the person, as a coherent process, is gone. From this point on, the story shifts from physiology to chemistry. Without an immune system actively policing it, the body becomes a rich, unprotected environment. Bacteria that were previously kept in check, especially in the gut, begin to spread. They digest tissues, releasing gases and breaking down complex molecules. Enzymes inside cells, no longer confined, continue to dismantle proteins and lipids. This process of self-digestion and microbial decomposition is not poetic. It is a straightforward flow of energy and matter from one form to another. Heat is lost to the surrounding air. The body cools toward ambient temperature. Water slowly evaporates or seeps into the soil. Organic molecules are broken into simpler compounds: carbon dioxide, methane, ammonia, nitrates. Insects and scavengers may accelerate the process, incorporating some of your atoms into their own bodies. Plants later draw nutrients from the soil, weaving your former components into roots, stems, and leaves. At every step, nothing disappears. It simply moves. Zoom in on a single carbon atom that was once part of a neuron in your brain. While you were alive, it sat in a chain, forming the backbone of a neurotransmitter or a membrane lipid. After death, as cells break down, that carbon might end up in carbon dioxide, exhaled by bacteria into the air. Carried by wind, it mixes into the atmosphere. A plant absorbs it during photosynthesis, using sunlight to link carbon atoms into sugars. An animal eats the plant, digests the sugar, and burns it for energy, releasing the carbon back into the air. Over years and centuries, that single atom might cycle through countless forms: leaf, muscle, soil, shell, cloud. Eventually, some of the atoms that were once arranged to think your thoughts and feel your fears may even escape into space, carried by tiny dust particles or evaporated into the thin upper atmosphere and pushed outward by solar radiation. They drift, perhaps, for millions of years. They never leave the universe, they simply change address. At no point in this chain is there a moment where matter or energy steps outside of reality. The first law of thermodynamics, conservation of energy, tells us that energy can change form, but the total amount remains constant. The second law, the growth of entropy, tells us that organized low-entropy structures, like a living body or a working brain, tend to break down into more disordered states over time. Your death is an example of both laws in action. The organized pattern decays, the pieces persist. This is the uncomfortable part for the idea of death as escape. What ends is not your matter, but your arrangement. The specific active pattern of atoms and electrical signals that produced you, your point of view, your narrative, your inner world, becomes unstable and collapses. Once the connections are gone and the structure is destroyed, that exact pattern does not spontaneously reassemble somewhere else. Physics offers no mechanism for a full, detailed copy of that pattern to jump to another realm at the moment of death. There are edge cases, such as near-death experiences, where people are revived after clinical death and report vivid perceptions. Whatever those experiences are, products of a struggling brain, memory reconstructions, or something not yet fully understood, they occur by definition in brains that resumed function. They do not show a pattern surviving the full physical breakdown of the system that generates it. As far as carefully tested science goes, when the brain structure and activity are sufficiently destroyed, the conscious process ends. Yet even here, the universe's refusal to provide an outside does not mean a clean, sharp erasure. The matter and energy that made you continue to participate in new stories. The warmth of your body becomes heat in the air. the chemical potential in your tissues becomes food for microbes and other organisms. The atoms that once formed the physical basis of your thoughts disperse into ecosystems, then into the wider environment, then, eventually, into the galaxy itself. From the universe's point of view, if such a thing can be imagined, death is not an exit event. It is a local reconfiguration. A highly ordered, statistically unlikely pattern relaxes back toward more probable, disordered states. What feels from the inside like an abrupt end is, from the outside, a continuation of the same physical story, governed by the same laws, with the same inventory of particles and fields. So if death is not a door out, but a reshuffling within, and if your atoms remain part of the universe's ongoing processes indefinitely, another question rises to the surface. What about information? The detailed arrangement of those atoms, the record that you ever existed in this particular pattern at all. Does the universe simply forget that, or does it keep a deeper, more permanent trace of every story it has ever told? To a living brain, death looks like a cliff. One moment, a continuous stream of experience, and the next, nothing at all. To physics, it looks less like a cliff and more like a slow landslide. The sharp boundary in your inner story is built on top of a gradual physical process called entropy, the universe's tendency to turn ordered structures into disorder over time. Entropy has a reputation for being an abstract, gloomy idea, but it shows up in everyday life. A sandcastle collapses, ice melts in a warm room, a hot cup of coffee cools down. In each case, a neat, organized state turns into a more chaotic one. The details differ, but the direction is always the same, from fewer possible arrangements to more, from special configurations to ordinary ones. Your body is no exception. While you're alive, your cells fight an endless war against entropy. They take in low entropy resources, food, oxygen, sunlight, indirectly, and use them to build and maintain structures that would never assemble themselves by random chance. Proteins fold into precise shapes. Membranes form controlled boundaries. DNA stores information in specific sequences. Your brain, especially, is a monument to low entropy. Billions of neurons, each with thousands of connections, organized into patterns that allow memory, language, and self-awareness. None of this defies the second law of thermodynamics. It works around it. Your body is not a closed system. You constantly dump entropy into your surroundings. You exhale warm, moist air. You radiate heat. You shed dead cells. The local decrease in entropy inside you is paid for by a greater increase in entropy outside you. Life is a temporary, delicate way of holding back the tide, a dynamic balance between order and disorder that must be actively maintained. Death is what happens when that maintenance stops. Once the heart no longer pumps and the brain no longer coordinates, the body stops importing low-entropy fuel and exporting waste. Chemical reactions don't halt, they just stop being directed. Molecules bounce and collide in whatever ways are statistically likely, without the guiding hand of metabolism. Organized structures, membranes, organelles, tissues, begin to break apart because there is no longer a constant input of energy to keep them intact. Enzymes, which are normally kept under tight control, continue to catalyze reactions, now in ways that dissolve the very structures they used to support. Proteins unfold and are chopped into smaller fragments. Lipid membranes rupture and leak. DNA is cut and fragmented. Water, always restless, seeps into spaces it was excluded from, swelling and bursting cells. Everything that was carefully compartmentalized begins to mix. From the standpoint of entropy, this is a huge release. Your body's highly improbable arrangement, billions of cells in an incredibly specific layout, loaded with stored energy and information, starts sliding toward far more probable arrangements. There are vastly more ways for your atoms to be scattered and disordered than there are for them to be precisely assembled into you. Over hours, days, and beyond, the system moves toward those more likely states. Heat flows out into the environment until your temperature matches the surroundings. Gases from decomposition expand and diffuse. Eventually, the remnants of your body are indistinguishable, thermodynamically, from the rest of the world around you. The sharp boundary between this is me and this is not me melts at the physical level. Your atoms and molecules lose their membership in the club you recognized as your body and join the general population of matter. This is the slow unraveling entropy and forces. It does not annihilate anything, it just scrambles. It takes a detailed pattern and mixes it into the background. You can think of it like a deck of cards. A specific ordered arrangement, say, all 4 suits sorted from ace to king, is special and unlikely. Shuffle long enough, and that precise arrangement will almost never return by chance, even though the cards themselves are always present. Death is that shuffling carried out by chemistry and time on an astronomical number of cards. Notice what this means for the idea of vanishing. The universe does not delete you, it dilutes you. The energy that once powered your thoughts becomes heat in the air and soil. The chemical bonds that once held your structure together are broken and reformed in other contexts. Your atoms are redistributed into new systems: plants, animals, rocks, the atmosphere. The difference between you alive and you gone is not a difference in total stuff. It is a difference in arrangement and accessibility. From your perspective, the moment consciousness ceases is absolute. Subjective experience seems to end completely because the process that generated it can no longer sustain itself. There is no half-awake brain left to witness the slow increase in entropy, the gradual breakdown of structure. That is part of why death feels like a clean cut. But the universe does not work in cuts. It works in processes. From the outside, what looks like a sharp border is just the steepest part of a curve. Even memory, not your personal memories but the universe's memory of you, is affected by this slow unravelling. Immediately after your death, there are countless traces of your existence. The arrangement of atoms in your body, the neural patterns in your brain, the footprints you left in the environment, the information in objects you built or influenced. Over time, entropy erases the finer details. Objects decay, records are lost, planets themselves are eventually reshaped or destroyed. The informational signature of your life becomes fainter, smeared out into more and more degrees of freedom. Yet, at a fundamental level, the laws of physics seem to hate true erasure. The microscopic details of how systems evolve, at least in quantum mechanics, are reversible in principle. Information is not supposed to be destroyed, only scrambled beyond recovery. Entropy measures how scrambled things are from the perspective of creatures like us, who can only track coarse details. As entropy grows, the precise story of you becomes encoded in ever more diffuse and inaccessible ways. This is the unsettling, almost paradoxical picture that emerges. The structure that makes you a conscious being decays under entropy's pressure. Your experience ends. The order you temporarily imposed on your little corner of the universe relaxes into disorder. But the universe does not forget in the sense of throwing anything away. It just scatters the record across so many particles and interactions that no realistic observer could ever reconstruct it. So the slow unravelling after death is not disappearance, but transformation. The universe takes back the low entropy pocket it lent you and returns it to the general flow. Your atoms and your energy remain part of the ongoing cosmic process, just in forms that no longer resemble a person. What is left of you is no longer a self, but a contribution to heat, to soil, to air, to future structures that have no idea where their materials once spent a brief, organised moment. This raises a deeper, more subtle question. If nothing is truly deleted at the most fundamental level, and if even the information about what once existed is somehow preserved in the fabric of reality, then in what sense does the universe remember that you are here at all? And how far does that kind of memory really go? If you could label every atom in your body with a tiny indestructible tag and then watch them for 1 billion years, what you would see would look nothing like an ending. It would look like migration. Those atoms would drift through air, dissolve in water, sink into soil, rise into clouds, burn in engines, flow through veins in other creatures. The afterlife of your matter is not a single destination, but an endless tour through new roles. Take a simple concrete path. You die and are buried. At first, your body is still recognisably you, the same arrangement of bones, muscles, organs, tissues. But as decomposition proceeds, that arrangement starts to loosen. Bacteria break down proteins, fats, and carbohydrates into smaller molecules. Carbon dioxide, methane, ammonia, and other gases are released. Liquids seep into the surrounding soil. The boundaries between you and not you blur. Soon, plants growing nearby begin to draw nutrients from that soil. Their roots take up nitrates, phosphates, and other molecules that were once part of your cells. Some of your nitrogen becomes part of a chlorophyll molecule in a leaf. Some of your phosphorus ends up in the backbone of plant DNA. Some of your carbon is stitched into sugars during photosynthesis, powered by sunlight. the same kind of starborn energy that once drove your own metabolism. An animal eats the plant. In its digestive system, your former atoms are broken free again and funneled into new structures. That nitrogen might now help build a muscle protein in a bird's wing. That carbon might become part of a fat molecule stored for later use. Eventually, those molecules are burned for energy or excreted back into the environment, where the cycle continues. Each transfer is mundane, but together, they trace an unbroken line of continuity. Even if your body is cremated, the story is similar. The high heat rapidly drives chemical reactions that break complex molecules into simpler gases and ash. Carbon becomes carbon dioxide, rising into the atmosphere. Tiny particles of mineral residue disperse on the wind or settle into the ground. In both cases, what changes is not presence versus absence, but structure. The universe keeps all the ingredients. It just stops honouring the recipe you recognise as you. Some of your atoms eventually reach the ocean. Rivers carrying dissolved minerals and organic fragments deliver them to the sea. There, they mix into a vast reservoir, joining the cycles that support marine life. A carbon atom that was once part of a neuron in your brain might become part of a shell, then part of sediment on the seafloor, then part of limestone rock. Millions of years later, tectonic forces could lift that rock into a mountain range. Wind and rain would erode it, returning those atoms to the air and water. Given enough time, some fraction of your atoms are likely to escape Earth altogether. Tiny dust grains, formed from soil or volcanic ash or pollution, can be lofted high into the atmosphere. Solar radiation and magnetic storms can slowly strip particles away. Impacts from meteoroids can blast material into space. On long timescales, the planet constantly trades matter with its surroundings. The odds are low for any single atom, but across trillions of atoms and billions of years, the universe is patient. Once in space, those atoms join an even larger circulation. They might drift as part of a sparse gas cloud, orbit the sun as dust, or even get pushed outward by radiation pressure into interstellar space. There, they could become part of the tenuous material between stars, a medium that, in time, may collapse under gravity to form new stars and planets. It is entirely possible that atoms that once helped form your body will be recycled into the chemistry of a distant world, orbiting a star that has not yet formed. The crucial point is that at no stage does your matter go anywhere outside the universe. There is no external sink where used atoms are thrown away. Conservation laws, of mass energy, of charge, of momentum, ensure that the universe keeps track of its inventory. What changes is how that inventory is arranged. The universe does not lose you, it repurposes you. This is very different from the way we talk about death. In everyday language, we treat it as disappearance. A person is here, then they are gone. Their absence feels absolute. The chair they used to sit in is empty. Their voice no longer sounds in the room. But if you zoom out from the level of experience to the level of physics, what you see is a redistribution. The matter and energy that made that presence possible is still part of the world, just no longer assembled into that one sharp pattern. Even the most intangible parts of your body's influence continue. The heat you radiated during your lifetime warmed the air around you. The food you ate came from plants and animals that depended on sunlight and soil and water, and your existence slightly changed the flow of all those resources. The waste you produced, the work you did, the objects you moved and altered. All of it nudged the state of the world in tiny ways. After your death, those nudges propagate. Air currents shift. Chemical concentrations change. Other organisms respond. Over long enough durations, the direct effects of your existence are diluted, mixed into the far larger patterns of climate, ecology, and geology, yet they never fully vanish. The butterfly effect is real in complex systems. Small perturbations can, in principle, create large changes over time. You cannot trace those changes backward with perfect precision. Entropy scrambles the trail, but on the most fundamental level, every action you ever took has become part of the universe's ongoing story. There is a temptation to downplay this, to say, sure, my atoms will be recycled, but that is not me, that is just stuff. And in a sense, that is correct. The subjective you, the inner point of view held together by a specific pattern of neural activity, does not glide intact into a tree or a bird or a star. The pattern dissolves, the components remain. What persists is not a continuous identity, but a contribution to the material and energetic flow. Yet this is exactly the point for the question of escape. The fact that your subjective experience ends does not mean you have stepped outside the universe. It means your role as a particular organized process has concluded and the universe has reassigned your parts. There is no outside waiting to receive you. There is only an inside that never stops rearranging itself. As your atoms and energy spread out, they become harder and harder to associate with you in any meaningful personal sense. A carbon atom in a distant tree does not carry your memories. A photon radiating away as heat does not preserve your personality. But from the universe's perspective, in terms of what exists and what continues, nothing has been lost. The inventory is the same, the ledger balances. So the afterlife of your atoms is not a consolation prize tacked onto the end of a vanished self. It is the continuation of what was always true. You were never a separate, sealed-off entity. You were a temporary configuration of shared materials, borrowed from a common pool and destined to return to it. Death does not create that connection. It reveals it in its starkest form. This sets the stage for a more subtle and haunting question. If the universe always keeps the pieces, and if even your influence echoes outward through countless chains of cause and effect, is there a deeper sense in which the universe remembers that you were once arranged in this specific way, not just as scattered atoms, but as information imprinted however faintly on the fabric of reality itself? In everyday life, information usually means something like a message, a memory, a file on a hard drive, something you can read, understand, and maybe delete. In physics, the word is colder and more fundamental. Information is, in simple terms, the detailed arrangement of a system. Which particles are where, what energies they have, how they are correlated. It is the answer to the question, out of all the ways this matter could be arranged, which particular way is it right now? Your life is one of those arrangements. Not just your body as a whole, but every microscopic detail, the exact connections between your neurons, the precise strengths of your synapses, the particular pattern of electrical activity flowing through your brain at each moment. That pattern is not mystical, it is physical. If you knew the state of every relevant particle in your brain with impossible precision, you could, in principle, encode you as an absurdly long string of bits. Physics has an uncomfortable rule about such strings. At the deepest level we currently understand, information seems to be conserved. That means the universe does not simply erase the details of how it was arranged. Systems evolve in ways that can, in principle, be reversed. If you could run the equations backward perfectly, you could recover earlier states from later ones. The problem is not that information is destroyed. The problem is that it gets scrambled beyond anything we could ever hope to reconstruct. Think of a drop of ink falling into a glass of water. At first, the ink is a tight, concentrated shape, a low entropy, information-rich pattern. You can easily see where the ink is and isn't. Over time it spreads, forming swirling tendrils and eddies, then a smooth, uniform tint. At that point it looks as if the original pattern is gone. But on a microscopic level, the positions and velocities of all the water and ink molecules still know what happened. The detailed trail of every collision is still encoded in their arrangement, just in a way so complex and sensitive that no realistic observer could ever work backward and separate ink from water again. Your life is like that drop of ink, but in a much larger container and with far more molecules. While you are alive, the universe's information about you is concentrated. It is relatively easy to find. It lives in your body, your brain, your belongings, the environment you've shaped. After you die and entropy does its work, that information spreads. The precise pattern of you becomes encoded in the positions, energies and correlations of countless particles in the air, soil, organisms and radiation that carry your influence forward. From a human perspective, that means the universe forgets you. No future scientist, no matter how advanced, will be able to gather all those particles and reconstruct perfectly what it felt like to be you on a particular afternoon decades earlier. The data is too widely dispersed and mixed with too many other processes. But from the universe's perspective, in terms of fundamental laws, the evolution from you alive to you decomposed and dispersed is a reversible transformation. The information is not annihilated, it is just lost to any practical form of recovery. This idea becomes unavoidable when you look at quantum mechanics. At that level, systems are described by wave functions that evolve according to equations that are mathematically reversible. If you know the wave function now, you can, in principle, compute what it was before. That is what information conservation means in this context. and it leads to one of the most famous puzzles in modern physics. What happens when information falls into a black hole? Black holes are regions of spacetime where gravity is so strong that, beyond a certain boundary called the event horizon, nothing, not even light, can escape. Throw matter into a black hole, and from the outside all you eventually see is a black object defined by just a few numbers: its mass, its charge, its spin. All the detailed information about what fell in, whether it was a star, a planet, a hard drive filled with data, or a human body, seems to vanish from the visible universe. This Hawking radiation appears to be featureless, random, thermal. If a black hole forms from something with a lot of information, say, a complex star, and then evaporates into a bland spray of random particles, it seems as though the information about what went in has been lost forever. That is the black hole information paradox. It is not just a niche argument about exotic objects. It is a direct clash between relativity and quantum mechanics, between gravity and information. Most physicists today believe that the paradox has only one acceptable resolution. Information cannot be destroyed, not even by a black hole. The details of how this works are still being hammered out, but one compelling idea comes from something called the Holographic Principle. In rough terms, it suggests that all the information about what falls into a region of space might be encoded on its boundary, like a hologram, rather than lost in the interior. Black holes, in this view, do not erase information. They scramble it and somehow re-encode it in their outgoing radiation. If that is true, and growing evidence from theoretical work in string theory and quantum gravity points that way, then the universe is far more stubborn about preserving information than common sense would suggest. Not only your atoms, but the information about how those atoms were arranged is something reality refuses to simply delete. It may become hopelessly entangled with everything else. It may be effectively unrecoverable, but it does not blink out of existence. So when asking whether the universe remembers you, the answer depends on what kind of memory is meant. If the question is whether your personal memories, your conscious perspective, your sense of self, persist in any recognizable way after your brain degrades, physics sees no mechanism for that. The pattern ends when the structure that implements it is destroyed. There is no known process that copies that full pattern to a safe location at the moment of death. But if the question is whether the universe keeps a record that you once existed in this particular way, the answer, as far as current physics can see, is yes, in a very cold, impersonal sense. The fact that you are here is stitched into the web of interactions that follow, into the distribution of particles and fields, into the ever-expanding tapestry of cause and effect. Not as a preserved self, but as an indelible change in the state of the whole. This view replaces the simple comfort of an afterlife with something stranger. You do not escape the universe, you become more deeply mixed into it. Your information does not stand apart as a protected file. It dissolves into the operating system itself, and yet, the universe does not, in the strictest terms, forget that you were once arranged this way. It just never offers a way to pull that arrangement back out as the you who is asking the question now. All of which leads to the next unsettling step. If even black holes have to respect information, and if the universe behaves as though every detail of every process is in some sense preserved, then the fabric of reality may be less like a stage and more like a cosmic ledger, one that records every interaction that ever happens, including yours. But to see how far that idea goes, you have to look more closely at black holes themselves, and why they forced physicists to rethink what never lost really means. Black holes are where the universe stops being polite and shows you how extreme its rules really are. They are not just massive objects. They are places where the usual intuitions about space, time, and information go to die. Or at least, that is what physicists thought at first. Picture a massive star at the end of its life. After burning through its nuclear fuel, it can no longer support itself against gravity. The core collapses inward. If the mass is high enough, there is nothing in known physics that can halt that collapse. The result is a region so dense with gravity so strong that beyond a certain radius called the event horizon, nothing can escape. Light, matter, signals, screams, all of it is pulled inexorably inward. From the outside, a black hole is deceptively simple. According to classical general relativity, it can be fully described by just three quantities: mass, electric charge, and spin. This is sometimes summarized as, black holes have no hair. All the messy details of what fell in are smoothed away. Whether you throw in a star, a planet, a pile of diamonds, or a library of hard drives full of data, the final black hole looks the same if those three numbers match. It seems as if the detailed information about what went in is gone. Stephen Hawking made the situation worse in the 1970s when he applied quantum field theory to the region near the event horizon. He found that black holes are not entirely black. Quantum fluctuations near the horizon allow pairs of particles and antiparticles to pop into existence. One falls in, the other escapes. To an external observer, the black hole emits radiation, Hawking radiation, and slowly loses mass. Over incredible timescales, a black hole can evaporate completely. Here is the problem. Hawking radiation, in his original calculation, is perfectly thermal. It carries no information about the specific things that fell into the black hole. If a black hole forms from a highly ordered, information-rich configuration and then evaporates into a featureless cloud of random particles, the detailed information about what it used to be seems to vanish from the universe. That is not just psychologically disturbing, it is a direct violation of information conservation in quantum mechanics. This is the black hole information paradox. On one side is general relativity, which treats the event horizon as a one-way boundary and suggests that whatever crosses it is effectively lost to the outside world. On the other side is quantum theory, which insists that the evolution of physical systems is reversible in principle and that information is never truly destroyed. If both theories are right in their domains, and they have been stunningly successful so far, how can they both be correct about black holes? For decades, physicists argued about what should give way. One extreme suggestion was that maybe quantum mechanics does break down in the presence of black holes, and that information can be destroyed after all. But that route leads to widespread chaos in physics. If information can vanish in one context, why not in others? The precise structure of quantum theory would need to be rebuilt from scratch. Most researchers considered that an unacceptable cost. Another idea was that information might somehow survive inside the black hole, even if it cannot get back out. When the black hole evaporates, perhaps the information remains trapped in a tiny remnant. The trouble is that this creates its own problems. Remnants would need to store arbitrarily large amounts of information, no matter how small they become, and nothing in our current understanding of physics supports such infinitely capable leftovers. Over time, attention shifted to a more subtle possibility, that Hawking radiation is not perfectly random after all. Perhaps it is subtly correlated, in a way Hawking's original calculation could not see. As the black hole emits radiation, these correlations could encode the information about what fell in. From far away, the radiation would look almost thermal, but with tiny deviations that, in principle, carry the lost data. When the black hole is gone, the information has been re-encoded in the outgoing radiation. This line of thinking led to deep work in quantum gravity and string theory. One influential development was the realization that the entropy of a black hole, a measure of how many internal states it can have, is proportional not to its volume, but to the area of its event horizon. This result, discovered by Jacob Bekenstein and refined by Hawking, suggests that the information content of whatever falls into a black hole is somehow stored on its surface, not in its interior. That strange hint inspired the holographic principle. The idea that all the information in a region of space might be describable by degrees of freedom on its boundary, like a hologram storing a three-dimensional image on a two-dimensional plate. In certain theoretical models, especially those using tools from string theory, this principle has been made concrete. A universe with gravity and a volume of space can be equivalent to a quantum system, without gravity living on that volume's boundary, with no loss of information between them. In that holographic view, black holes do not destroy information. They hide it, and then gradually release it in encoding so scrambled that it might as well be lost to any realistic observer. From the universe's bookkeeping perspective, though, the ledger balances. Every bit that went in comes back out, distributed in the subtle correlations of the Hawking radiation. The paradox is resolved not by letting information die, but by recognizing that the universe stores it in ways we did not initially expect. Of course, the details are still being worked out. There are fierce debates about how exactly information escapes. Proposals like firewalls, violent energetic barriers at the event horizon, and ideas about quantum entanglement between the inside and outside of black holes have pushed physicists to rethink basic assumptions about spacetime. But the broad consensus is shifting toward a clear conclusion. Information is safe. even in the most extreme places the universe can create. What does any of this have to do with you? Black holes are not part of your daily life. You're not falling into one, and yet the message they send is directly relevant. If the universe refuses to let information be destroyed in the most violent, extreme environment we know, then it is unlikely to be more casual about the information that made you in ordinary contexts. When you die and your pattern dissolves, the universe does not break its own rules. It does not erase, it scrambles. This does not mean there is a hidden backup copy of you stored somewhere, waiting to be reassembled. The way information is preserved in physics is not friendly to personal identity. It is cold, distributed, and essentially unrecoverable in practice. But it does mean that at the most fundamental level, your existence leaves a permanent mark on the state of reality, one that cannot be undone, only buried under layers of entropy and complexity. Black holes forced physicists to confront how seriously the universe takes information. They turned, maybe things just disappear, from a casual assumption into a deep problem, and then into a clue that reality is, in some sense, always keeping score. Once you accept that, it is hard to see death, or any process, as a true exit from the game. It is merely a change in how your part of the score is written. This leads to an even more radical idea. If information about everything that happens is, in principle, encoded on boundaries and preserved, then the universe might be less like an open-ended ocean and more like a kind of cosmic memory, a structure in which every event, including the brief pattern called you, is permanently inscribed. To understand how far that view can go, you have to look at what happens when this holographic way of thinking is applied not just to black holes, but to the universe as a whole. The weirdest idea to come out of black hole physics is that the universe might be more like a hologram than a solid three-dimensional thing. Not an illusion, but a reality where the deepest description lives not inside but on the edges. It sounds like science fiction, yet it falls straight out of the attempt to solve the information paradox you just saw. The key clue was almost embarrassingly simple. When Jacob Bekenstein and Stephen Hawking worked out how much entropy, how many possible internal states, a black hole can have, they found that it scales with the area of its event horizon, not its volume. Double the radius of a black hole and its volume increases eightfold, but its entropy only grows with the square of the radius, because area grows that way. Somehow the number of ways a black hole can be arranged is tied to its surface. In ordinary matter, entropy tends to scale with volume. More space, more particles, more ways to arrange them, more information. Black holes break that pattern. They suggest a strange bookkeeping rule. A region of space can contain only so much information, and that maximum is proportional to the area of its boundary. It is as if reality is whispering that the true degrees of freedom live on surfaces, not in the bulk. Gerard 't Hooft and Leonard Susskind took that whisper seriously, and proposed the holographic principle. In rough terms, it says that everything happening inside a volume of space could be fully described by a theory living on the boundary of that volume, with one bit of information per roughly Planck-sized patch of area. Just as a two-dimensional hologram can encode a three-dimensional image, the boundary can encode the interior. This is not just a metaphor. In a particular kind of universe, one with a negative cosmological constant, a curved spacetime known as anti-de Sitter space, physicists found a concrete realization of this idea. It is called the AD-CFT correspondence. On one side, there is a theory of gravity in a bulk spacetime. On the other, there is a quantum field theory without gravity living on the boundary. These two descriptions, wildly different in language, turn out to be equivalent. Every process in the bulk has a translation on the boundary. In that framework, a black hole in the bulk corresponds to a hot, dense state in the boundary theory. The black hole's entropy matches the entropy of the boundary system. Information that seems to vanish behind a horizon in the bulk is still present and accounted for in the boundary description. The paradox dissolves, not because information is magically rescued at the last minute, but because it was never truly lost from the fundamental boundary perspective. Our universe is not anti-de Sitter space. It appears to have a positive cosmological constant, more like de Sitter space, with accelerated expansion. Extending the holographic principle to this more realistic setting is difficult, and still an active area of research. But the underlying lesson is hard to ignore. Gravity and quantum mechanics seem to conspire to enforce a kind of holographic limit on information. The maximum amount of information in a region is tied to its boundary area. Volume is not the fundamental measure, area is. What does that imply about the universe you inhabit? At minimum, it suggests that the full, microscopic description of everything that ever happens might be encoded on cosmic horizons, surfaces beyond which you cannot see. The inside description you experience, galaxies, stars, planets, your body, could be something like a derived picture, a way of organizing that underlying information into a three-dimensional story. This does not mean your reality is fake, like a simulation on a computer. The holographic picture is not about illusion, it is about redundancy. The same physics can be described in multiple mathematically equivalent ways. One uses a bulk spacetime with gravity. The other uses a lower dimensional system without gravity, living on a boundary. Both are real descriptions of the same thing. From the standpoint of information and escape, this is unsettling in a new way. If the universe obeys a holographic principle, then everything that ever happens inside, every particle collision, every star's life, every human thought, is, in principle, encoded on some bounding surface. Nothing falls out of the description. There is no event that is not written somewhere in the cosmic ledger. Imagine very loosely that your life is like a pattern written in light on the interior of a vast dome. From where you stand, you see only the local scene, your room, your city, your planet. You experience events in sequence. You are born, you live, you die. But from the perspective of the dome surface, the boundary encoding, your entire history is part of a static, incredibly complicated pattern. It does not move, it simply is. Every interaction you ever have is one more stroke in that pattern. Again, this is only an analogy, and real holographic dualities are more abstract and mathematical than this picture suggests. The point is that in such a universe, inside processes cannot fall off the map. There is always an equivalent description where the information is preserved on a boundary. If a black hole cannot hide it, if quantum gravity insists on keeping it, then your existence, as a specific arrangement of matter and information, is also something the universe never fully drops. This does not rescue personal identity in any comforting way. The holographic record is not a backup of your consciousness that can be rerun like a video. It is a complete bookkeeping of all the microscopic correlations that ever involved you. The pattern that corresponds to you asking this question is one small patch in an incomprehensibly vast mosaic. There is no reason to think that pattern, once it stops evolving in the bulk description, resumes somewhere else as an active experience. But it does sharpen the core theme. There is no outside. Whether you think in terms of particles moving in spacetime or bits encoded on cosmic horizons, everything that happens, including your birth, your life, and your death, is part of one closed informational system. Nothing leaks out. Nothing is imported from beyond. The universe is not a volume inside a larger warehouse. It is the complete set of all these patterns and their lawful evolution. In that sense, you are doubly inescapable. Your atoms never leave the material universe, and the information about how they were once arranged as you never leaves the universe's informational accounting. Once you have existed, that fact is woven into the structure of reality in a way that cannot simply be undone, even if it can be buried, blurred, and rendered meaningless to any finite observer. So the holographic hint is this. The universe might not only refuse to let you escape physically, it might also refuse to ever fully erase your trace informationally. You are a pattern that appears once in the total cosmic record and cannot be subtracted. What that means for how we think about time, memory, and identity is another question entirely, one that leads straight into the way the universe treats past, present, and future as parts of a single, inescapable whole. Time feels like motion. You wake up, you move through your day, you remember yesterday and imagine tomorrow, and all of it seems to flow along a one-way track from past to future. Death, in that picture, is the end of the track, the moment your carriage reaches the last station and stops. But physics paints a stranger view, where the track is less something you travel along and more something that simply exists, all at once. In our experience, the past is gone, the future is not yet real, and only the present is truly there. This is called presentism in philosophy, the idea that only the present exists. Relativity, the theory that ties space and time together, has a hard time accommodating that. Once you accept that the speed of light is the same for everyone, and that time can pass at different rates for different observers depending on their motion and gravitational field, the notion of a single, universal now starts to fall apart. Imagine two people moving relative to each other far out in space. Each of them can slice space-time into what they call past or present and future. But those slices do not line up. Events that are now for one observer can be already past or not yet for the other, without either being wrong. There is no special cosmic clock ticking in the background that defines an objective, shared present across the entire universe. This leads to a view sometimes called the block universe. In this picture, space-time is like a four-dimensional landscape. All events, past, present and future, are points in that landscape. They do not come into existence or slip out of existence. They simply are. Your life is a long, thin world line, a curve through this landscape, beginning at your birth, meandering through all your experiences and ending at your death. From the outside perspective of the block, that entire curve exists as one seamless object. From the inside, as a conscious being moving along that world line, you experience events in sequence. You remember earlier segments of the curve and anticipate later ones. But you never step outside the curve to watch it from above. You never see the whole. The impression of a moving present, of time flowing, is something your brain constructs as it processes change. Physics, as far as it can tell, does not need that flow. It needs only the structure. If that is even approximately the right way to think about time, then the idea of leaving the past becomes tricky. You do not outrun your childhood by growing older. Your childhood is a region of space-time where you are younger. You simply move to a different part of your world line. When you die, the segment of space-time containing your living body and conscious experience does not vanish. It remains a fixed part of the block. What changes is that there are no events after a certain point where your brain is functioning. No more segments of the curve where you are awake and aware. From your perspective, death is the end of experience. There is no future segment where you can stand and look back. But from the universe's four-dimensional perspective, your entire life is there. Birth, growth, love, fear, questions, and finally, silence. Like a complete story printed on a film strip. The fact that the strip has a last frame does not mean the earlier frames cease to exist. It just means there is nowhere on the strip where the character continues beyond that point. This is a very different way of thinking about never escaping the universe. You're not a traveller trying to get out of a room. You're part of the room's architecture. Once the universe has written your world line into its fabric, that line is part of reality as long as the universe has any meaning at all. You cannot jump off it into some meta-time. You cannot change it from outside because there is no outside time in which to do the changing. The one-way direction you feel, the arrow of time, comes from entropy. The past is the direction of lower entropy. The future is the direction of higher entropy. You remember the past because your brain has stored information about earlier states. You cannot remember the future because that information does not exist yet along your world line. But in the block picture, both low entropy past states and high entropy future states are parts of the overall structure. The arrow is not a railroad track being laid down in front of you as you walk. It is a gradient in the landscape that your experiences line up with. This perspective also reframes what it means for the past to no longer be real. When a star dies, we say it is gone. When a civilization falls, we say it no longer exists. But in space-time, those events are simply located earlier along certain world lines. They have their place in the block, fixed and unchanging. The fact that you, here and now, cannot interact with them is a statement about causal structure and light cones, not about their ontological status. For your own life, this means something quietly profound. The time during which you are alive and conscious is a finite region of space-time. It is bounded at the beginning by the conditions that make your brain possible, and at the end by the conditions that destroy its ability to function. Between those boundaries lie all the moments you will ever experience. Once they have happened, they are not stored in some external vault. They are part of the universe's structure, in the same sense that the existence of a distant galaxy is part of it. You might ask, if my entire life is already laid out in space-time, does that mean everything is predetermined? Is there no real choice? That question slides into philosophical territory, but from the viewpoint of the block universe, the distinction between determined and happening is not as sharp. All events are simply part of the total pattern. Whether that pattern was fixed from the beginning or emerges from deeper quantum uncertainties, it still has the property that once it exists, there is nowhere outside it from which to jump to a different version. It is important to be honest here. This picture does not grant you a comforting immortality. It does not say, you go on after you die, experiencing new chapters. It says that the chapters you do experience are eternally part of the book. Your presence in the universe is finite in duration, but permanent in description. There is no cosmic delete key that goes back and removes the pages where you were alive. There is also no way to step out of the book and start a new volume somewhere else. Combine this with what you have already seen. Your atoms never leave the universe. Your information, in a deep physical sense, is not destroyed. Your entire lifespan is a fixed structure within spacetime. All of these point to the same conclusion. You're not something that temporarily visits the universe and then departs. You're a feature of the universe's history, and history and physics is part of what the universe is. So when thinking about escaping the universe by moving forward in time, dying, and hoping to land in some qualitatively different mode of existence, the block picture says there is nowhere for that landing to happen. Time is not a hallway with a hidden doorway that opens after the last second of your life. It is the entire corridor, walls and floor and ceiling, with your path already embedded in it. This way of seeing time is unsettling, because it takes away the fantasy of a clean break and replaces it with a kind of inescapable inclusion. Yet it also suggests a different kind of permanence. Even when your future is empty of new experiences, your past, every moment you are alive, remains woven into the universe's fabric. You never outrun that. You never step beyond it. At most, your role as an experiencing pattern ends, while your existence as part of the total cosmic story does not. Once you accept that, another question naturally follows. If the universe is this fixed, inescapable stage of matter, energy, and information evolving in spacetime, how separate were you ever really from the rest of it? Or have you always been just one temporary pattern in a much larger interconnected web that was never other than you in the first place? When you look at another person, an animal, or a distant galaxy, it is easy to feel a clean separation. Here is you, over there is everything else. The word universe becomes a kind of backdrop, a stage on which you happen to be standing. But if you follow the physics all the way down, that border between you and everything else starts to dissolve. You're not on the stage. You're one moving pattern in the stage itself. On the larger scales, the universe is not random clutter. Galaxies are not sprinkled through space like sand. They form a structure called the cosmic web, an immense network of filaments and nodes made of dark matter, gas and stars, stretching over hundreds of millions of light years. Where filaments intersect, galaxy clusters form. Between them, there are vast, underdense voids. The pattern looks eerily like a neural network, or the branching of veins in a leaf, scaled up to a size that makes every human concern microscopic. Zoom in on one of those filaments and you find galaxies like the Milky Way, each containing hundreds of billions of stars. Around many of those stars are planets, some rocky, some gaseous, some frozen. On at least one of them, Earth, the chemistry of those star-forged elements has become complicated enough to question its own existence. Nothing about this hierarchy suggests sharp boundaries. It is all continuous, gas condensing into stars, stars spreading heavier elements, those elements forming planets, planets forming environments, environments spawning life. The same continuity exists at smaller scales. Inside your body there is no single point where you stop and the rest of the universe begins. Your lungs are open tunnels to the atmosphere. Every breath pulls in molecules that were outside a moment ago and will be outside again shortly. Your gut is a continuous chemical reactor connected to the biosphere, packed with microbes that outnumber your own cells and help digest food that came from plants and animals rooted in the wider ecosystem. Your skin is not a sealed shell, but a porous exchanging surface. Even in your blood, you carry traces of the larger world. Hormones responding to light and darkness, chemical signatures of what you ate, pollutants from distant industry, dust from ancient deserts. The boundaries we draw around the human body are useful abstractions for medicine and anatomy, but they are not absolute. They are like borders on a map, lines that help us talk about regions, not walls that matter respects. At the microscopic level, the interconnectedness becomes even harder to ignore. The oxygen atom in a hemoglobin molecule in your blood was in the atmosphere minutes ago, perhaps part of a molecule exhaled by someone else. Before that, it might have been in a leaf, bound into water, drifting in a cloud. Over years and centuries, your atoms trade places with those in other bodies, other organisms, other bits of rock and water. You and your environment are constantly sharing material, like dancers swapping partners in a crowded hall. The same is true for energy. The photons that hit your eyes and skin are bits of sunlight, emitted by the sun's nuclear reactions 8 minutes earlier. Inside your cells, chemical reactions take the stored energy from food, itself originally captured from sunlight or chemical gradients, and turn it into motion, heat, and electrical signals in your nervous system. You're literally powered by a star every second. Your thoughts are, in a very direct sense, one way the sun's energy moves through the universe. On cosmic scales, gravity ties everything together. Every mass in the universe attracts every other mass. The effect is tiny over short distances and small masses, but it never reaches zero. Your body pulls on the moon pulls on you, distant galaxies pull on the Milky Way, and the combined gravitational field of the cosmic web shapes how clusters and voids evolve. When you move, however slightly, you are, in principle, changing the gravitational field everywhere by a minuscule amount. You're not just in the universe, you're participating in its shape. Quantum mechanics adds another layer of connection. Particles are not tiny billiard balls with definite positions and trajectories. They're excitations of underlying fields, spread out and interacting. In many situations, particles become entangled, their properties linked in ways that cannot be fully described independently. Change the state of one, and you change the joint state of the pair, no matter how far apart they are. Entanglement does not let you send messages faster than light, but it does show that the universe is not built from independent, self-contained pieces. It is built from relationships. None of this is mysticism. It is textbook physics and biology. The cosmic web, the interchange of atoms, the flow of energy, quantum entanglement, all point toward the same picture. The universe is a single, connected system. You are a local pattern in that system, defined by certain boundaries and processes, but those boundaries are fuzzy, and those processes rely on constant exchange with the rest. This has consequences for how to think about escape. If you imagine yourself as a separate entity, standing apart from the universe, then escaping means stepping away from it, leaving it behind like a room you can exit. But if you are, in reality, a pattern the universe is briefly instantiating, like a whirlpool in a river or a flame in a candle, then escape stops making sense. The whirlpool cannot leave the water. The flame cannot walk away from the fuel and oxygen that sustain it. When they end, the water and the air remain, changed but continuous. Even your mind, which feels so private, is built from interactions with the outside. Your memories are not just internal images, they are records of past exchanges, photons that once bounced off objects into your eyes, sounds that once vibrated your eardrums, words spoken by other people, sensations from your body. Your personality is shaped by culture, language, and relationships, all of them patterns that exist between individuals, not inside any single skull. The self you defend and fear losing is stitched from countless threads that were never solely yours to begin with. So when the body dies and the brain falls apart, it is not a sealed object breaking in isolation. It is one node in a vast network changing state. The universe does not lose an outsider. It rearranges part of itself. The atoms that were you remain part of the cosmic web of matter. The energy that powered you remains part of the cosmic flow of radiation and heat. The information that described you remains, however scrambled, part of the universe's total informational state. You were never on the outside looking in. You were always on the inside as a temporary configuration of the inside. The idea of escaping the universe in this light is like a wave on the ocean, asking when it will get to leave water and be somewhere else entirely. It misunderstands what it is. The wave is a behavior of the ocean. You are a behavior of the universe. This does not answer the emotional side of the question, the fear of not existing as a conscious self. Physics does not offer comfort there. It does, however, strip away the illusion that you were ever a visitor. There is no hotel to check out of. There is only the building itself rearranging its rooms. Once that sinks in, the question starts to flip. The real mystery is not why you can't escape the universe. It is how, out of this interconnected web of matter and energy, a pattern like you was able to appear at all. A piece of the universe that could look back at the whole and ask where, if anywhere, it might go when it's gone. Somewhere in your skull, about 1.5 liters of soft grey tissue is doing something no star, no galaxy, no black hole has ever been seen to do. It is generating a point of view, not just electrical activity or chemical reactions, but the feeling of being someone, here, now, looking out at the world and wondering what happens when that view goes dark. Whatever consciousness is, it is not an extra ingredient poured into the universe from outside. It is what happens when the universe arranges matter in a very particular way. Start with the basics. Your brain is made of ordinary atoms: carbon, hydrogen, oxygen, nitrogen, a few metals, all forged in ancient stars and assembled into cells. Those cells, neurons and glia, obey the same physics as any other matter. They use electrical charges and chemical gradients to send signals. They consume energy, produce waste, obey thermodynamics. There is no special mind substance hiding between the atoms. As far as is known, consciousness is a pattern, not a material. A neuron is a device for taking input signals, integrating them, and producing an output. One neuron is not conscious, but your brain has around 86 billion of them, each linked to thousands of others in immense layered networks. Some clusters process vision, some handle sound, some regulate movement, some store and retrieve memories. On top of that, there are networks that monitor and modulate other networks. Attention, self-reflection, meta-awareness. Out of this tangled hierarchy emerges what you call me. From the outside, it is all physics, ions flowing through membrane channels, neurotransmitters crossing synapses, electrical pulses travelling along axons. From the inside, it is experience, the colour red, the taste of coffee, the ache of loss, the fear of non-existence. How those two descriptions line up, how patterns of activity and matter produce subjective experience, is one of the deepest open questions in science and philosophy. But whatever the solution is, it is not expected to involve violations of physical law. That matters for the idea of escape. If consciousness is a process that runs on physical hardware, a pattern of information flow in a physical brain, then it is constrained by the same rules as any other physical process. It depends on energy, structure, and interaction. When those conditions fail, the process stops. There is no sign in current neuroscience or physics that a conscious pattern can simply detach from its hardware and continue somewhere else, independent of any physical substrate. Think of a whirlpool in a river. The water flows in complex ways, creating a recognizable structure, spinning, persistent, with a shape you can point to. The whirlpool is not a separate object added to the river. It is a behavior of the water. If the flow changes, the whirlpool weakens and disappears. The water remains. The pattern does not. You cannot scoop up the whirlpool itself and move it to another river. You can only recreate a similar pattern if the conditions are right. Your consciousness seems to be like that. The atoms remain. The energy remains. The information, in a fundamental sense, is never fully destroyed. But the specific ongoing pattern of activity that constitutes being you, tracking the world, remembering the past, anticipating the future, feeling like a single subject, depends on precise conditions in a functioning brain. When those conditions go away, the pattern stops. Physics offers no known route for that exact pattern to jump to a new substrate automatically at the moment of death. Some speculate about uploading minds to computers, scanning every neuron and synapse and emulating the pattern in silicon. Even if that becomes technically possible one day, a huge if, it would not be an escape from the universe. It would be a new, physically implemented pattern inside the same universe, obeying the same laws. And it raises the uncomfortable identity question. Would that copy be you, or a new conscious being that merely shares your memories? Physics can describe the pattern. It cannot decide which perspective deserves the name. Others imagine a soul, a non-physical essence that survives the body and moves to another realm. That is a metaphysical idea, not a scientific one. By definition, a soul as something outside physical law leaves no trace in the equations or experiments that describe matter, energy, and information. Physics does not disprove it, but it does not need it. Everything observed about brains and experience so far can be explained in terms of neurons, chemistry, and networks without invoking an extra ingredient that can slip away to somewhere else. What science does show, over and over, is that consciousness is fragile. It depends on blood flow, temperature, chemistry, and structure. General anesthesia can make it vanish temporarily by gently altering the brain's signaling. A stroke can erase parts of it permanently by damaging specific regions. Neurodegenerative diseases can slowly dismantle memory, personality, and self-awareness. As the brain's pattern degrades, the conscious experience changes accordingly. There is no sign of a stable, unchanging you that persists unaffected while the hardware falls apart, and yet there is something profound hiding in this fragility. Consciousness is not an alien visitor. It is something the universe can do with itself under very specific conditions. It is what results when star-forged atoms are arranged into a particular kind of network, bathed in energy, exchanging information with an environment. In that sense, a conscious being is the universe becoming locally aware, a patch of matter that has learned to model itself in its surroundings, and to worry about what happens when it stops. Seen this way, the idea that you could ever leave the universe becomes even stranger. You're not a ghost inhabiting matter. You're what a certain kind of matter, obeying universal laws, feels like from the inside. If the matter remains within the universe, and if the laws remain the same, then whatever happens to consciousness happens within that framework. There is no outside for a pattern to flee to, only different ways for patterns to exist or end inside the same physical reality. This does not solve the hard problem of why experience exists at all. It does not tell you why neural activity is accompanied by a feeling of being someone, rather than just silent computation. But it does anchor the phenomena in the universe instead of outside it. However mysterious consciousness is, it appears as a property of complex physical processes, not as a visitor from beyond physics. So when the brain dies and the pattern stops, the universe does not lose an outsider. It ceases to instantiate that particular form of self-awareness. The atoms and energy that made it possible continue in other forms. The information about what happened is, in a deep sense, preserved and scrambled into the wider world. What does not continue is the ongoing first-person experience, the point of view that was asking the question. If that seems bleak, remember what it implies in the other direction. Before you were born, star matter and simple chemistry, over billions of years, eventually produced a pattern that could feel, think, and ask about its own fate. Consciousness is not a default state. It is a rare configuration, a delicate phase of matter. Your life is that phase, briefly. You did not exist outside the universe before it began, and you will not exist outside it after you're gone. You exist as a way the universe, for a while, knows itself from the inside. That realization pushes the focus away from impossible escapes and toward a different kind of question. If a conscious self is a temporary pattern in a universe that never forgets its patterns completely, what happens when that universe itself ages, cools, and moves toward its own distant horizon, where stars go dark and even the possibility of new conscious patterns fades away? The universe feels eternal because on human timescales it is. Stars are born, live, and die over millions or billions of years, and even that already dwarfs our entire history. But cosmology pulls the camera back much further. It asks what happens not just to one star or one galaxy, but to everything, given enough time. The current best answer is not a fiery apocalypse, but a long, cold fading. A heat death in which even the possibility of new minds eventually disappears, yet nothing ever truly leaves. Right now, the universe is in what you might call its middle age. Stars are still forming from collapsing gas clouds. Galaxies collide and merge. Black holes grow by swallowing matter. There is structure, activity, and plenty of free energy. Differences in temperature and density that can be tapped to do work, like driving fusion in stars or metabolism in living cells. This free energy is what allows low entropy pockets like planets and brains to exist in a higher entropy background. But star formation is already slowing down. The universe has been expanding for 13.8 billion years, and as it expands, gas in galaxies is used up or thrown out. There is less cold, dense material available to make new stars. Over the next trillions of years, the existing stars will burn through their fuel. The most massive ones will die quickly in spectacular supernovae. Smaller red dwarf stars will burn slowly, glowing dimly for trillions of years. Eventually, they too will run out of fuel. After about 10 trillion to 100 trillion years, depending on the details, star formation effectively stops. The era of luminous, hydrogen-burning stars ends. The universe enters the so-called degenerate era. What remains are stellar remnants, white dwarfs, neutron stars, black holes, and cold, dark planets and debris. The bright, starry universe you know becomes a much quieter place, lit only by the fading glow of cooling remnants. Even then, change continues. White dwarfs, initially hot and bright, slowly radiate away their heat over immense timescales. They cool and darken, becoming black dwarfs, dead stars made of ultra-dense matter, no longer shining. Protons inside some of these remnants might decay if theories that allow proton decay are correct, turning matter into lighter particles and radiation over unimaginable spans of time, perhaps 10 to the 34 years or more. If protons are truly stable, the remnants will simply persist, cold and dark. Gravitational interactions slowly reshape this dark universe. Stars and remnants in galaxies can exchange energy through close encounters, kicking some objects into intergalactic space and causing others to sink toward the center. Over time, many galaxies are expected to become dominated by central supermassive black holes, with much of their original mass either swallowed or ejected. The cosmic web thins as structures relax and expand. Black holes themselves then take over the story. They do not last forever. Hawking radiation ensures that even the most massive black holes will eventually evaporate, albeit on timescales that make the current age of the universe look like an eye blink. A stellar mass black hole might take around 1067 years to evaporate. A supermassive black hole, like the one at the center of the Milky Way, could take around years. The largest black holes we know of might survive for up to years or more. During that evaporation, black holes slowly convert their mass into a trickle of particles and radiation, heating their surroundings ever so slightly as they fade. At the end of this process, all that remains of the luminous structured universe is a diffuse sea of low-energy photons and light particles, the debris of all previous processes diluted by ever-expanding space. This is the heat death. It is not a sudden event, but a limit state. A universe that has run down its gradients. Entropy has climbed toward its maximum. Temperature differences have smoothed out. There are no more free energy sources strong enough and concentrated enough to power complex low-entropy structures like living organisms or stars. In such a universe, nothing interesting, in the sense we're used to, can happen spontaneously. Fluctuations still occur, but they are tiny, random, and extraordinarily unlikely to produce sustained complexity. From the perspective of conscious beings, this is the final curtain. There is no future era where new civilizations will rise on new worlds, because there is no energy budget to support them. If any minds or machines linger into this era, scraping by on dwindling energy, they will face harder and harder limits as the universe cools and thins. Eventually, even the most patient strategies for stretching out thought, slowing down subjective time, spacing out computations, will run up against the fact that there is simply not enough usable energy left. For you, personally, this might seem irrelevant. You will be gone long before the last star goes out, but it underscores the same theme that appears at every scale. There is no external place where existence continues when the universe itself runs down. The laws of thermodynamics do not suddenly stop. The conservation of energy does not suddenly allow exports to a higher reality. The universe does not hand off its contents to some larger stage when it has finished its run. It simply approaches a state where change becomes thin and uneventful. Even in the heat death, though, nothing literally disappears. The matter and energy that once formed stars, galaxies, and living beings are still present, spread thinly across a cold, dark cosmos. The information about what happened, about every star that shone, every life that existed, remains encoded in some deeply scrambled form in the distribution and correlations of those particles and fields. If black hole physics and holography are right, even the apparent erasures are bookkeeping shifts, not true deletions. In that distant future, there will be no new conscious patterns emerging to ask questions about their situation, no new observers to worry about escape. But the traces of all previous patterns will still be there, part of the universe's final, frozen ledger. Every world line, including yours, will still be a thread in the tapestry of spacetime, even if the tapestry is no longer actively weaving new designs. The irony is sharp. The universe appears to head for a state where nothing new can arise, but not one bit of what did arise is truly lost from its total description. You cannot outlive the universe. You cannot ride its expansion into some beyond. You cannot count on some later, more hospitable arena. Your existence is confined to the eras when there is enough free energy to support complexity, and those eras are finite. So on the largest scale imaginable, the story is the same as on the human scale. There is no outside waiting at the end. There is only a long, fading process within, where structure arises, thrives, breaks down, and finally becomes part of a cold, uniform background that still contains, in principle, the memory of everything that came before. Against that landscape, a natural temptation appears. Maybe there are other universes, other bubbles of reality with their own arrows of time and their own fresh supplies of free energy, places we might escape to when this one runs down. But when you look closely at what other universes could even mean, you find that they do not offer a true outside either. At best, they are more rooms in the same inescapable building of existence, not a door that leads beyond it. When the universe starts to look like a closed story with a beginning, a middle, and a cold, fading end, the imagination reaches for a loophole. Maybe this isn't the only story. Maybe there are other universes, other realms with their own big bangs, their own laws of physics, their own arrows of time. If this one is heading for heat death, perhaps some part of you or us could slip sideways into another, like changing trains at a cosmic station. Modern physics does entertain the possibility of a multiverse, not as a single, neat idea, but as several different concepts that share the same unsettling word. One version comes from inflation, the rapid expansion thought to have occurred in the first fraction of a second after the Big Bang. In many models, inflation doesn't stop everywhere at once. It ends in some regions, creating bubble universes like ours, while continuing in others. The process can be eternal, spawning an endless patchwork of universes with different properties. Another version comes from quantum mechanics. In some interpretations, especially the many worlds interpretation, every quantum event with multiple possible outcomes actually realizes all of them, each in its own branch of a larger wave function. The universe, in that view, constantly splits into non-communicating branches. There is not one reality, but a vast tree of them, each containing different versions of events and observers. Still other possibilities come from string theory, where different ways of compactifying extra dimensions can produce universes with different effective laws, or from speculative ideas about black holes spawning new universes inside their singularities, each with slightly tweaked constants. Collectively, these scenarios paint a picture of reality that might be much larger than the observable universe, more like an endless landscape than a single island. At first glance, this sounds like an escape hatch. If there are other universes with more free energy, different laws, or fresh starts, maybe death is not the terminal end it appears to be. Maybe consciousness can jump tracks. Maybe there is a version of you that wakes up somewhere else. But when you look closely at what these multiverse ideas actually say, the door quietly closes. Start with inflationary or string landscape multiverses. In those, different universes are separated by enormous stretches of inflating space, or by fundamental differences in structure. They are not adjacent rooms with doors between them. They are causally disconnected regions of a larger reality. No signal, no ship, no field can travel from our bubble to another. Even if those other universes exist, they are not places you can go. They are parallel stories written in the same unreachable ink. Quantum many worlds is even less friendly to the notion of personal escape. In that interpretation, every time a quantum event with multiple outcomes occurs, the universe's wave function branches. There is a branch where the coin lands heads, and one where it lands tails, a branch where you survive the accident and one where you don't. But you never jump from one branch to another. Each branch contains its own version of you, with its own continuous stream of experience, confined to that branch's history. From your point of view, you follow one path through the branching tree. The existence of other branches where different things happen does not create a place for you to escape to at death. When the branch you are on reaches a point where your brain ceases to function, there is no further segment of that path where your consciousness continues. Other branches may contain other versions of you that lived longer or died differently, but they are not waiting rooms you can transfer into. They are separate, non-communicating stories. Even more speculative ideas like universes budding off inside black holes do not rescue the concept. If a collapsing region of spacetime forms a new expanding region on the inside with its own time and space, it is still connected to ours only through the mathematical structure of a larger theory. No physical traveller from our universe survives the crushing gravity and singularity to step into the new one. At best, our universe contributes to the initial conditions of another. It does not provide a portal for your ongoing subjective experience. In all of these scenarios, the common feature is this: the other universes are not outside reality. They are part of a bigger reality. If the multiverse exists, it is not an escape from the universe. It is the full structure of what the universe really means. You're already inside it, as one small process in one region or branch. There is no outside of the multiverse to leap into, only other regions you are causally or quantum mechanically disconnected from. From a strict physics standpoint, nothing in multiverse ideas changes the local rules that govern your life and death. Your brain still depends on energy and structure. Entropy still increases. Information is still scrambled, not deleted. When your local pattern fails, there is no known mechanism for you to be copied or transported to another bubble, branch or sector. The existence of other universes, if real, adds more pages to the cosmic book, but it does not allow the character in one chapter to suddenly wake up in another. There is also a more subtle point. Multiverse theories are so far on speculative ground. Some arise naturally from models that explain real data, but the other universes they predict are not directly observable. You cannot point a telescope at them. You cannot send probes. You infer them, at best, as parts of a mathematical structure that also describes the universe you do see. Leaning on them as afterlife destinations is like planning to move into a house you have only seen in someone else's dreams. What they do emphasize, however, is that even our own universe may not be the whole story, and yet whatever the whole story is, it is still a single, unified structure. Whether there is one universe or many, one branch or a branching tree, one bubble or a frothing sea of them, the same conclusion stands. There is no reason to think there is an outside of all of it, where existence stops and something fundamentally other begins. So multiverses, far from offering an escape, deepen the sense of inclusion. If they exist, you're already part of that larger reality, as one finite local pattern. Your atoms, your information, your world line all live inside whatever the full structure is. When your pattern ends here, that does not mean you move to another. It means your part of the full structure has a finite extent. That leaves more grounded fantasies of escape, not by jumping to another universe, but by transcending biology inside this one. Upload your mind, merge with machines, simulate new worlds, live forever as software. These ideas at least keep their feet in physics. But even they, on close inspection, turn out to be rearrangements within the same inescapable framework, not exits from it. When people realize that bodies are fragile and the universe is indifferent, the conversation often shifts from souls to servers. If you cannot escape the universe by dying, maybe you can escape biology by uploading. Copy your mind into a machine, run it on hardware that can be repaired and upgraded. Let your consciousness live in virtual worlds that never age. It feels less like religion, more like engineering. But even at its most optimistic, this vision does not break you out of the universe. It just moves your pattern to a different corner of it. Start with what uploading would actually mean in physical terms. Your mind is not a glowing ball floating above your head. It is a process, the dynamic activity of a brain laid out in 3 dimensions, with specific connections and signaling patterns. To upload that process into a computer, you would have to measure with extraordinary precision the structure and state of your neurons, which are connected to which, how strong each synapse is, what chemicals are present, maybe even the exact distribution of ion channels and receptor types. Then you would need a machine capable of simulating all of that in real time, running a model of your brain's activity at a resolution fine enough that the emergent behavior, consciousness, memory, personality, is preserved. That machine would have to obey the same physics as any other matter. It would live in a data center, orbiting habitat, or deep space structure. It would require energy, cooling, maintenance. It would be vulnerable to hardware failures, cosmic radiation, accidents, and, on long timescales, the same thermodynamic limits that threaten any complex system. Even if all of that were possible, and a colossal if, it would not move you outside the universe. It would relocate your mind to another substrate inside it. Your thoughts would be patterns in electrical currents and magnetic domains in chips, not patterns in chemical and electrical signals in neurons. The laws governing those chips would be the same laws that govern your brain: electromagnetism, quantum mechanics, thermodynamics. You would still be constrained by the speed of light, by entropy, by the availability of energy. There is also the identity question. Suppose a scan copies the exact state of your brain into a computer, while your biological brain continues to exist. Now there are 2 conscious beings with your memories, your personality, your preferences, both claiming to be you. You experience only one viewpoint. If the biological you then dies, the digital copy continues, but from your perspective, there was a break. You did not feel yourself slide into silicon. The continuity is in the pattern, not necessarily in the sense of self. Whether you consider that survival or replacement is a philosophical choice, not something physics can adjudicate. More drastic schemes, where the brain is gradually replaced neuron by neuron with artificial equivalents while you stay awake, raise similar issues. They try to preserve continuity by making the transition seamless. If, step by step, every biological neuron is swapped for a functional synthetic one, and your experience remains smooth throughout, you might reasonably feel that you have become a machine mind. In that case, uploading is less like copying and more like an extended transformation. But again, there is no escape from physics. You're still a process in the universe, now running on engineered hardware. Virtual worlds do not change that. A simulated environment is still a physical process. Bits flipping in memory, voltages changing in circuits. The people inside it, if conscious, are patterns implemented in that same hardware. They can experience different laws inside the simulation, faster time, rewound states, invented physics, but the simulation itself is limited by the real universe that runs it. It needs energy, it generates heat, it cannot compute infinite detail, it cannot run forever if the universe cannot. Some speculate that advanced civilizations could build enormous structures, Dyson spheres around stars, galaxy-scale computers, to host vast numbers of digital minds. They imagine a future where physical reality is mostly quiet matter and energy, while most subjective experience happens in engineered environments. But thermodynamics does not go away. Computation generates heat. Heat must be dumped into a colder reservoir. As the universe cools and free energy dwindles, even the most efficient computers face hard ceilings. At best, minds can slow their subjective time, spacing out thoughts to stretch their existence. They cannot outrun the ultimate exhaustion of usable energy. Even more radical is the notion that our universe is already a simulation, running on some external substrate in a higher level reality. In that picture, escaping would mean somehow contacting or moving into the base reality. But this is layered speculation on top of speculation. There is no empirical evidence that we live in a simulation, and even if we did, the simulated universe, with all its matter, energy and laws, would still be the only reality accessible to the beings inside it. From their point of view, the outside exists only in theory. They cannot reach it unless the simulator intervenes. Physics, by design, contains no hooks for that. From a strict scientific standpoint, all forms of digital or simulated immortality are relocations of patterns, not exits from existence. They keep consciousness going by tying it to new structures that are themselves subject to the universe's constraints. Death becomes a technical failure of the hardware and software rather than a biological one. But it is still a failure that will eventually happen if the surrounding universe runs down. There is, however, a subtler sense in which digital minds emphasize the same point as everything else discussed so far. Whether implemented in carbon or silicon, consciousness remains a way the universe organizes itself. A machine mind is not outside nature, it is nature, configured differently. If a digital version of you one day exists, that entity will be as bound to the universe as you are now, limited by the same causal structure, the same speed of light, the same thermodynamic horizon. So even the wildest dreams of technological transcendence keep circling back to the same conclusion. You can change substrates, you can change environments, you can prolong the pattern that feels like you far beyond biological limits, at least in principle. But you cannot step outside the framework that makes any pattern possible. You will still be made of something, somewhere, following some version of the same laws. You will still be in the universe. That brings the conversation back from speculative futures to something even stranger and more firmly grounded: the quantum rules that govern matter at the smallest scales. Superposition, entanglement, uncertainty. These phenomena make reality look flexible and fuzzy. It is tempting to hope they might provide some loophole for consciousness to slip through. But when you unpack what quantum mechanics actually says, it turns out to reinforce, not weaken, the sense that there is no elsewhere to go. Quantum mechanics is where reality stops behaving like the solid, sensible world you grew up with and starts acting like something much stranger. Particles are waves. Waves behave like particles. Outcomes are probabilistic. Systems can be in superpositions, multiple states at once, until you look. Two particles can become entangled so that measuring one instantly tells you something about the other, no matter how far apart they are. It is tempting to look at all this weirdness and think, there, that's the loophole, that's where souls or minds or escape routes might hide. But when you strip away the mystique and look at what quantum mechanics actually lets you do and not do, the opposite picture emerges. Quantum behavior does not open a door out of the universe. It reveals how deeply everything is woven into the same underlying reality. Take superposition. A particle, like an electron, can be described by a wave function, a mathematical object that encodes all the possible states the particle could be in and the probabilities of finding each one when you measure it. Before measurement, the particle is not in one definite place. It is in a superposition of many possible positions. When you measure, you get one specific result, and the wave function collapses to reflect that outcome. It is easy to misunderstand this and imagine that measurement is some special act that reaches in from outside physics. In reality, measurement is just an interaction. Your detector is made of atoms and fields. When it interacts with the particle, they become entangled. The detector's state and the particle's state are no longer independent. They are part of one, larger wave function. What looks like collapse is, in more careful treatments, the result of this entanglement plus decoherence, where interaction with the environment effectively hides the superposed alternatives and leaves you with one classical-looking outcome. Entanglement is even stranger. When two particles interact in certain ways, their states become linked. You cannot describe one without referencing the other, even if they later move far apart. Measure the spin of one particle, and you instantly know the spin of the other in a way that violates classical intuition. But this does not let you send messages faster than light, or teleport information across the universe outside the usual causal structure. The correlations show up only when you compare results after the fact. The underlying theory still respects the speed of light limit and the same space-time geometry. The important point for escape is this: quantum mechanics does not add a new place where things can go. There is no separate quantum realm where particles or consciousness live when they are not being observed, and then jump into classical reality when someone looks. There is one reality described at different levels. At small scales and low energies, you need quantum rules. At larger scales, those rules average out into the classical behavior you see every day. The gap between them is not a portal, it is a change of description. Some popular ideas misinterpret this. You might hear that consciousness collapses the wave function, implying that minds have a special non-physical role in deciding what becomes real. In the early days of quantum theory, some interpretations flirted with this idea, but modern physics does not need it. Decoherence and entanglement explain why certain outcomes become effectively classical without invoking a ghostly observer outside the system. The measuring device, the environment, and the particle are all part of the same quantum universe. Whatever consciousness is, it arises in brains that are themselves quantum systems behaving mostly classically at large scales. Neurons fire or don't fire. Signals propagate. Thermal noise and decoherence wash out delicate superpositions very quickly in warm, wet tissue. Your brain is not a quantum computer maintaining coherent superpositions across billions of neurons. It is a robust, noisy network where quantum effects matter locally, but do not produce magical non-physical channels. Quantum tunneling, where particles cross barriers they shouldn't classically be able to, is another piece of strangeness that still plays by the rules. A particle can appear on the other side of an energy barrier without having enough energy to climb over it. But tunneling does not break conservation of energy overall, and it does not provide a way to tunnel out of the universe. It is a way of moving within the allowed quantum configuration space of this universe, not a way of leaving that space. Even the many worlds interpretation, with its endless branching of outcomes, does not grant an exit. If the universe's wave function includes many branches where different things happen, each branch is still part of the same overarching quantum state. You, as experienced from the inside, inhabit one branch. There is no known mechanism for jumping from one branch to another, especially not after your branch has reached a point where your brain no longer supports consciousness. The existence of other branches with other versions of events does not rescue you from the fate of the branch you are on. Quantum field theory goes further and says that particles are excitations of fields that fill all of space. There is an electron field, a photon field, and so on. What you think of as a particle is a localized ripple in that field. When a particle is created or destroyed, the field changes state. The fields themselves are not created or destroyed. They are features of the universe. Again, there is no outside reservoir where fields go when they are off. They are just quiet. The stage remains. If anything, quantum mechanics deepens the sense that reality is a single unified structure. Entangled particles, superposed states, vacuum fluctuations, all are aspects of one quantum state evolving according to precise rules. The uncertainty and randomness you see in measurement outcomes are not signs of an external realm of freedom, but reflections of how probabilities and information work inside this one. So where does this leave the idea that quantum effects might allow consciousness to slip free at death? So far, there is no support for that in serious physics. The breakdown of a brain is a thermodynamic biochemical process. Quantum effects play a role at the level of molecules and reactions, as they do everywhere, but they do not open a new category of existence. The wave functions of the particles in your brain continue to evolve as part of the universe's overall quantum state. The specific pattern that corresponds to you, aware and thinking, becomes entangled and scrambled with everything else, its coherence lost. There is no sudden jump to a different reality. Quantum weirdness does, however, reinforce a key theme. The universe is not made of discrete, isolated objects that could, in principle, be plucked out and transplanted elsewhere. It is made of fields and states and relationships, all evolving together. You're not a self-contained thing that could be carried across a border. You're a particular, fleeting configuration in a much larger quantum story. If there is a comfort here, it is not in loopholes, but in participation. The same rules that govern distant quasars and tiny particles also govern your thoughts and choices. The strangeness of superposition and entanglement is not happening somewhere else. It is happening in the fabric that includes you. You are not outside the weirdness, you are made of it. And this brings the journey almost full circle. The universe, from quantum fields to cosmic webs, from black hole horizons to heat death, appears as a single, inescapable system. You never came from outside it. You never step outside it. Even after death, your matter, your energy, and your informational fingerprint remain inside it, endlessly rearranged. The remaining question is what that means for the idea of you, the self that feels separate and temporary, and how to live with the knowledge that you are and always have been a phase of the universe rather than a visitor. Nothing sounds like the ultimate escape. If you could somehow get beyond the universe, beyond space, beyond time, beyond matter and energy, you might imagine arriving in a kind of pure absence, a blank, timeless void where nothing exists and nothing ever happens. For some, that sounds terrifying. For others, oddly comforting. But in physics, nothing turns out to be one of the most misleading words we have. The closer you look at it, the less it behaves like a place you can go. In everyday language, nothing means no thing, no objects, no matter, no light. An empty room, an evacuated box, deep intergalactic space. But even those empty places are not truly empty. A vacuum chamber still has electromagnetic fields and the quantum vacuum. Intergalactic space still has stray particles, dark matter, radiation, and the structure of space-time itself. The more precise you get, the harder it becomes to find a region that is genuinely devoid of everything. In physics, the closest thing to nothing is often called the vacuum state, the lowest energy state of a quantum field. But even that is not a simple, featureless emptiness. Quantum fields never sit perfectly still. They fluctuate. Pairs of particles and antiparticles can appear briefly and annihilate. These vacuum fluctuations have real measurable effects, like the Casimir force between closely spaced metal plates. Empty space has properties. It can bend around mass, expand, and influence how particles behave. Even the cosmological constant, the energy density of empty space, seems to be non-zero. Dark energy, whatever it is, appears to act like a constant push built into the vacuum itself, driving the accelerated expansion of the universe. In that sense, nothing has a kind of pressure. It is not a backdrop you can remove. It is part of the machinery. Crucially, the vacuum is not somewhere you can go. It is not a location outside the universe. It is a state of the universe. When you remove particles from a region, cool it down, and strip away as much structure as possible, what remains is not a hole in reality. It is the vacuum state of the fields in that region. The fields are still there. Space-time is still there. The laws are still there. You're just closer to their ground state. This matters for the idea of escape. If you imagine death as slipping into nothing, it sounds at first like stepping into a metaphysical void. Outside all realities, outside all rules. But physics does not recognize such an outside void. It recognizes only different configurations of the same underlying fields and geometry. The most nothing you can get, physically, is a high-entropy, low-energy vacuum state with no excitations. No particles, no radiation, just quiet fields in their ground state. That is not elsewhere. That is just a particular way for the universe to be. You might try to push even further and imagine the absence of spacetime itself. Not empty space, but no space. Not a quiet vacuum, but no fields. That is conceptually extreme. All of our theories are built on the assumption that there is a stage, some structure in which events can be located, even if that structure is dynamic and curved. To talk about nothing beyond that is to step outside physics into pure abstraction. There is no coordinate system, no clock, no possibility of change. It is not a place, it is the absence of having anywhere to be. And that is the core issue. To go somewhere, you need a notion of location and time, a way to say here and then. If you truly remove space-time, there is no where or when left. The question, where do you go when you die, stops making sense if the supposed destination has no coordinates, no duration, no structure. There is no journey to be made. There is only the end of the pattern that was capable of asking the question. Physics, as actually practiced, does not deal with that absolute nothing. It deals with states of something, different arrangements of fields, particles, and geometry. Even the initial Big Bang is not cleanly described as a moment when nothing became something. It is better thought of as a hot, dense, rapidly expanding state from which our observable universe evolved. What, if anything, came before is either undefined in our current theories or described by speculative models that still assume some sort of underlying structure. So when people say, after I die there is nothing, they usually mean there is no longer any experience, no ongoing consciousness. From the inside, that is a reasonable shorthand. When the brain's pattern fails, there is no more subject to witness anything. Subjective nothingness is not a place you arrive at. It is the absence of a subject entirely. There is no one there to report on it. From the universe's perspective, though, even that nothing is just another state of something. Your atoms continue to exist in other forms. Your energy becomes heat and motion elsewhere. The information about your existence is scattered into the environment, scrambled but not obliterated. The region of space-time that contained your life remains part of the block. The vacuum state, if reached locally, is still a physical configuration, not a whole in being. This may sound like splitting hairs, but it cuts directly into the fantasy of escape. There is no external reservoir of nothingness you can fall into to be free of the universe. The only nothing physics can talk about is always a way the universe is arranged, a limit state, a ground state, a condition of maximum entropy, never a separate realm. You can stop being a particular pattern, a particular conscious process. You cannot step into non-being as if it were an address on some map. In other words, nothing is not a destination. It is a description of what it is like from the inside when something that used to be there is gone. From the outside, from the viewpoint of the universe's laws and inventory, there is always something. Some fields, some geometry, some distribution of matter and radiation, some record, however diffuse, that this region once hosted a living system that asked about its own ending. So the myth of absolutely nothing, a clean outside into which you can disappear, dissolves under scrutiny. There is only the universe, in different states, some rich with structure and consciousness, others barren and quiet. Death moves you from one kind of state, an organized experiencing pattern, into another, a dispersed inanimate distribution. Both are inside the same reality. Once that sinks in, the question shifts again. If there is no outside, no pure nothing to escape into, then the idea of getting away from the universe loses its literal meaning. What remains is the question of identity. In a cosmos where everything is just different arrangements of the same underlying stuff, what does it even mean to say you exist or cease? And how tightly should you cling to a boundary that physics never fully draws? If you strip away the stories and look only at the physics, something uncomfortable happens to the word you. It stops being a solid object and starts looking like a moving target, a pattern that changes from moment to moment, made of parts that don't stay put, embedded in a world that never stands still. In a universe where everything is just different arrangements of the same underlying stuff, the question, what happens to me, becomes harder to pin down than it first appears. Start at the most basic level. The atoms that make up your body are not uniquely yours. They were borrowed from the environment and will be returned to it. Over the years, most of the atoms in your brain and body are replaced, taken in through food, water, and air, and then excreted, shed, or recycled. Yet you feel like the same person you were a decade ago. Whatever you are, it cannot be a fixed collection of atoms. The specific particles come and go. The pattern persists. Even that pattern is not constant. Your brain rewires itself constantly. New synapses form, old ones weaken or disappear. Memories are written, updated, and sometimes overwritten. Personality traits can shift with experience, trauma, or slow, gradual change. The person you were at 5 years old and the person you are now are recognizably linked but not identical. The continuity you feel is a narrative, the brain's ongoing story about itself, stitching together changing states into a sense of a single enduring self. From a physics perspective, you are a set of correlated processes, neural activity, bodily regulation, relationships with the environment, that maintain a certain degree of coherence over time. That coherence is real, but it has no sharp boundary. Sleep, anesthesia, coma, and injury all show that consciousness can fade, fragment, or alter without a simple on-off switch. The self is more like a region on a map than a point, a cluster of functions and memories bound together for a while. This fuzziness doesn't mean you are an illusion in the trivial sense. It means that you are a higher-level description, useful for organizing what happens at the scale of brains and behavior, but not fundamental in the same way as fields and particles. The universe does not contain a labeled object called you that it can keep or discard. It contains matter and energy arranged into a process that, among other things, generates the idea of being someone. Death, in this view, is not the disappearance of a solid thing. It is the breakdown of that process. The pattern that ties your memories, experiences, and bodily functions into a coherent whole loses integrity. The correlations that made your brain a unified system dissolve. There is no longer a dynamically maintained region of the universe that fits the description, "This is one conscious subject with this history and this perspective." The components remain. The particular organization that justified using the word you does not. So what does it mean to say you still exist, or you no longer exist in a universe like this? You exist in a strong sense, as long as the pattern that underlies your consciousness is functioning, as long as there is a continuous chain of brain states, each linked strongly enough to the last by memory and structure that it makes sense to call them stages of the same self. You exist, in a weaker sense, as long as the information about those states is preserved in any usable form, in your brain, in recordings, in the environment. You exist, in the weakest physical sense, as long as the matter and energy that supported those states remain part of the universe's inventory, which is effectively forever. Death cleanly ends the first sense, the ongoing first-person experience. It gradually erodes the second as memories fade from other minds, records decay, and entropy scrambles fine-grained information. It never touches the third, because nothing in physics allows the universe to give up its matter, energy, or total information content. In that weaker sense, the fact that you once existed never stops being true. It is permanently woven into the structure of reality. The trouble is that our emotional lives are anchored in the first sense. When you say, "I don't want to die," you're not worrying about your atoms being recycled differently, or the universe forgetting a few bits. You're worrying about the end of your point of view, the loss of the ongoing story from the inside. Physics has very little to say directly about that feeling. It can describe the conditions under which the pattern stops, but it cannot turn that stoppage into a continuation. What it can do is undermine some of the fears hiding behind the words. When you fear non-existence, you might picture falling into a blank void, being trapped in nothingness. But there is no you to be trapped when the process stops. There is no local experience of nothingness. There is simply the absence of new experiences. Before you were born, there was no you suffering the lack of existence. After you die, physics suggests a similar absence. Not a state you're in, but the end of there being a you to be in any state at all. At the same time, the idea that you never escape the universe takes on a different flavour. If the self is a pattern, and the universe is the medium in which patterns form, then you were made of the universe from the start. You did not fall into it from somewhere else. You were not inserted into matter like a pilot into a vehicle. You were one of the ways matter, under these laws, briefly organised itself, In that sense, you are never fully separate from the universe to begin with. That perspective softens the sharpness of the boundary between you and everything else. The line is still useful, morally and practically. Your pain matters more to you than a distant star's fate, but it is not absolute. The very distinction arises from a particular kind of information processing going on in one corner of reality. When that processing stops, the universe does not lose a fundamentally separate entity. It loses a particular way of drawing a line. This does not tell you how to feel about death. Physics cannot assign meaning, it can only describe structure and change. But it does suggest that the identity you are trying to protect, the isolated, self-contained me, who might somehow step outside the universe, is not quite what you think it is. The self is real, but not as a thing that could ever float free of the physical story. It is real as a temporary pattern in that story, difficult to let go of, but never truly apart from the whole. Once you see yourself as a phase the universe is going through, rather than a separate visitor, never escaping starts to sound less like a sentence and more like a statement of fact. You cannot leave what you never stood outside of. The more interesting question then becomes not whether you can get away, but how to live with the knowledge that you are a finite, fragile pattern in an infinite, indifferent system, and whether that can be a source of meaning rather than just fear. Take a glass of water and start cooling it down. Above 0 degrees Celsius, it is a liquid, flowing, sloshing, taking the shape of its container. Drop the temperature and at some point something dramatic but ordinary happens. The same H2O molecules, obeying the same laws, reorganize into a solid crystal. The water hasn't vanished, it has changed phase. What it can do, and how it behaves, depends entirely on that phase. You're like that, but more complicated. For most of the universe's history, matter existed in relatively simple phases: plasma, gas, dust, stars, rocks. Over billions of years, under the right conditions, some of that matter entered a very rare, very delicate phase: life. Within that phase, an even narrower sliver appeared: nervous systems and eventually brains complex enough to support consciousness. You, sitting here wondering about your fate, are one of those phases, a temporary high-order configuration the universe can adopt under the right circumstances. This is not metaphor so much as hierarchy. At the bottom level there are fields and particles, above that atoms and molecules, above that cells and organs, above that organisms, societies, cultures. Each level has its own patterns and rules, but they are all built on the same underlying substrate. When someone says, "You are the universe experiencing itself," it can sound like a slogan. In the phase picture, it has a more precise meaning. A certain arrangement of universal ingredients yields a pattern that includes self-awareness as one of its properties. That pattern is dynamic. It is not the same from one moment to the next. Every second, billions of neurons fire, chemicals are released, signals propagate. Your self is not a static object. It is a trajectory, a particular way the universe's state evolves in a region of spacetime. For a few decades, that trajectory supports a coherent self-modeling process. From your perspective, that feels like being alive, being me. From the universe's perspective, if such a thing could exist, it is just one of countless patterns it cycles through. Like convection cells in the atmosphere or vortices in a turbulent flow, conscious beings are structures that appear, persist for a while, and dissolve, all without adding or subtracting anything fundamental from reality's inventory. They are not visitors, they are episodes. Thinking of yourself as a phase of the universe changes the question from "how do I escape?" to "what does this phase mean?" When water freezes, it loses some abilities and gains others. It can no longer flow, but it can support weight. It reflects light differently. Likewise, when matter enters the life and mind phase, new capacities emerge: sensation, valuation, planning, curiosity, fear. The universe gains, locally, the ability to care about things, to assign importance, to imagine futures that do not yet exist. Those capacities are not illusions. They are as real, at their level, as temperature or pressure. A temperature is not a single particle. It is a property of many particles together. Similarly, meaning and value are not properties of single atoms, but of organized systems of atoms like brains and cultures. As long as the phase of matter called you exists, those properties are active. They shape behavior. They change what happens next, within the constraints of physical law. When that phase ends, When the brain can no longer maintain the patterns that underlie awareness, those capacities vanish from that region. The universe in that spot becomes simpler again. No more self-reflection, no more anxiety about death, no more plans. But the raw materials and the laws that allowed such a phase in the first place remain. They continue to operate elsewhere, maybe supporting other lives, other forms of awareness, other questions. This perspective undercuts both extremes. The idea that you are a trivial accident that means nothing, and the idea that you are a separate essence that must be preserved at all costs. You are not trivial, because the phase you represent is astonishingly rare and delicate. It took billions of years of cosmic evolution and planetary history for star matter to organize into something that asks, "Why am I here?" That rarity gives your existence weight. At the same time, you are not separate. You are a way the universe briefly arranges itself and then unarranges, without adding anything foreign to the total. You can see this layered unity in every direction. Your thoughts about your own mortality are neural events, driven by chemical gradients powered by food that came from plants that captured sunlight, from a star that formed from gas, enriched by dead stars that formed from hydrogen left over from the early universe. The worry in your chest, the logic in your head, the words describing them, all of it is one continuous chain of cause and effect, stretching back to conditions long before Earth existed. From that vantage point, never escaping the universe is not a trap. It is a restatement of your identity. You're not in the universe like a passenger in a ship. You're of it, like a wave in water or a wind pattern in air. When the wave passes, the water remains. When you die, the universe remains, altered in small but permanent ways by the fact that this particular phase once occurred. You might be tempted to ask whether that makes your individuality unimportant. If you're just a phase, why should your specific trajectory matter? The answer depends on the level of description. At the level of fundamental physics, one pattern is as good as another. The equations do not rank them. At the level of lived experience, the fact that this pattern feels like something from the inside is everything. Without faces like you, the universe would be mute. It would do things, but nothing would be there to register that anything was happening. So seeing yourself as a phase of the universe is not about erasing your significance, it is about relocating it. Your importance does not come from being separable and eternal. It comes from being a finite, fragile, conscious episode in a reality that, for the most part, is not like that. The very impossibility of escaping the universe is what makes your brief time as a self-aware pattern so striking. There is nowhere else this could have happened, and that leads naturally into an emotional shift. If escape is impossible because you are the universe in a particular configuration, then the fear of being trapped starts to lose its footing. What remains is a different kind of question. Given that you are a temporary phase in a vast indifferent system that will neither save you nor single you out, how do you relate to that system? With dread, with indifference, or with a kind of awe at having existed at all? At first glance, the idea that you can never escape the universe sounds like a nightmare, like being locked in a room forever, with no doors, no windows, no way out. Space stretches to infinity. Time rolls on without you. The laws of physics are indifferent. You're born inside this system, you live inside it, you die inside it, and even your remains never leave. It is easy to hear that and feel a kind of cosmic claustrophobia. Part of that reaction comes from a story most minds tell by default, that there is me on one side and everything else on the other. If you see yourself as a separate, permanent essence temporarily trapped in a fragile body, then of course you dream of escape routes. Heaven, reincarnation, digital immortality, parallel universes, pure nothingness. Different cultures and eras pick different exits, but the underlying hope is the same. When this ends, maybe something fundamentally different begins. Physics quietly dismantles that picture. It says there is no outside space to move into, no outside time to start a new clock in, no demonstrated mechanism for a conscious pattern to lift itself out of the substrate that sustains it. Your atoms stay here, your energy stays here. The information about what you were is scrambled but not erased into the same reality that made you possible. If that reality ever had an edge, nothing seen so far points to it. You do not get out. Emotionally, that can land like a sentence. No parole, no elsewhere, just the universe, forever, with or without you. But that reaction smuggles in an assumption. that you were ever something separable that could have gone somewhere else in the first place. The earlier sections have been chipping away at that. You're star matter in a brief, intricate arrangement. You're a pattern of activity in a brain that depends on constant exchange with its environment. You're one phase of the universe's behaviour, not a foreign object inside it. Once that sinks in, no escape starts to feel different. It is less like a prison and more like a definition. Waves do not escape the ocean. Flames do not escape combustion. They appear, they transform energy and matter, and they fade, leaving the medium changed. The wave was never a prisoner of water. It was how water, under certain conditions, moved. The flame was how fuel and oxygen, under certain conditions, reacted. You are how the universe, under certain conditions, becomes aware of itself and asks questions. This does not erase fear. The end of consciousness is still the end of everything you care about from the inside. There is no physical argument that makes that feel fine, but the fear shifts. It is no longer about being thrown out of existence into some alien nothingness, or trapped forever in a place you do not belong. It is about a temporary pattern ending in the only universe there is, a universe that has already been running for billions of years without you, and will continue for billions of years after. Seen from that angle, the inescapability of the universe has a strange comfort built into it. You cannot fall out of reality, because there is nowhere to fall to. You cannot miss the boat to some higher realm, because there is no second harbour. You do not have to worry about being left behind by existence itself. You are and always were inside all of it. It also means that nothing about your life is off to the side. There is no backstage. Every moment you live, every thought you have, every decision you make is part of the main show, the only show. When you help someone, when you hurt someone, when you create something, when you waste time, all of it is written into the same fabric as supernovas and black holes and expanding space. The universe is not watching or judging, but in a literal physical sense, it is registering your actions in its state. This can cut both ways. On bad days, it might make everything feel heavy, every choice an irreversible mark on a cosmic ledger. On good days, it can make even small things feel oddly significant. You're a finite pattern in an infinite system, but that system will never produce another pattern that is exactly you, with exactly this history, asking exactly these questions. The impossibility of escape is also the guarantee that this one appearance is your only shot. There is another emotional twist. The same physics that denies you an outside also connects you to everything inside. The atoms in your body came from ancient stars. The energy powering your thoughts came from the sun. The air in your lungs has been through countless other organisms. Gravity ties your mass to distant galaxies. Quantum fields link every region of space. You're not an intruder in the universe. You're made of its oldest stories, rearranged. That sense of belonging can coexist with the knowledge that the universe does not care in any human sense whether you exist. It would have been fine without you. It will be fine after you. The meaning you find or create is not handed down from outside. It is a property of your phase, something that exists while your pattern runs and nowhere else. That might feel fragile, but it is also honest. Whatever matters to you matters because you are here to let it. So the emotional impact of you will never escape the universe depends on which part of the story you emphasize. If you cling to an image of yourself as a sealed, permanent self trapped in alien machinery, it will feel suffocating. If you see yourself as a temporary conscious pattern in the only reality there is, it can start to feel like something else. Not victory over death, not cosmic punishment, but participation. You get one finite stretch of time during which the universe, in your region, is in a phase that includes curiosity, fear, joy, and the ability to hear sentences like these. Before and after, the same underlying reality goes on without that feature. Never escaping means that what you do with that phase is not practice for somewhere else. It is the whole thing, and that sets up the final turn. If you're not a visitor who might one day check out, but a piece of the universe briefly waking up in human form, then the question shifts one last time, from "how do I get out?" to "given that I am the universe, in this particular fleeting configuration, how should I relate to my own ending?" Some fears are simple: fear of pain, of sickness, of losing people you love. The fear of death is stranger. It points in two directions at once. On one side, there is the fear of what might happen after. Punishment, judgment, endless emptiness, some unknown state you cannot control. On the other side, there is the fear that nothing happens at all, that you simply stop. The idea that you will never escape the universe cuts across both fears in an unexpected way. If there is no outside, no other realm of space or time to move into, then the universe is not handing you off to an alien system when you die. There is no separate cosmic courtroom, no parallel reality with new rules. The same laws that ran your life run your death and whatever follows physically. Your body fails. Your brain stops sustaining a conscious pattern. Your matter and energy are redistributed. Your information is scrambled into the environment. All of it happens inside one continuous reality. That does not mean you go on in the personal sense. Physics does not support the idea that your subjective experience continues somewhere else as the same self. The specific pattern that underlies your awareness ends when the brain is irreversibly damaged. There is no known mechanism that transfers that pattern intact to another substrate at the moment of death. The part of you that says I and means it does not get a sequel, at least not according to any established science. So what changes is not the fact of ending, but the frame around it. Death is not a border crossing. It is not a cosmic relocation. It is a local transformation in a system that does not have an outside. From your perspective, the light goes out. From the universe's perspective, the pattern that created the light has run its course, and the pieces are moving on. There is no extra realm waiting to punish or reward you. There is also no abyss of pure non-being for you to fall into, because there is no you left to do the falling. For many people, part of the fear of death comes from picturing themselves as conscious in a bad situation, trapped in darkness, stranded in an empty void, or frozen at the edge of time. Physics quietly removes those scenarios. Consciousness depends on a functioning brain. When that condition fails, there is no longer a subject to experience anything, good or bad. The worst nightmares, eternal pain, eternal isolation, eternal boredom, all require an ongoing mind. The laws of biology and thermodynamics do not permit such a mind to persist without a substrate. On the other side, the fear of just nothing can soften when you recognize that you have already experienced it in a way. Before you were born, billions of years passed. Stars formed and died, galaxies collided, dinosaurs lived and vanished. None of it felt like waiting in a blank room. There was simply no you to be present. After you die, physics suggests a similar absence from the inside. Not an endless grey fog, but the end of there being anyone to notice the fog. What remains, then, is not the problem of your fate in some other realm, but the question of how to relate to the reality that your life is finite and unrepeatable within this one. If you are the universe, in this configuration, for this limited time, what do you do with that? Fear will not vanish just because the picture is clearer, but it can change shape. You might start to see that the urgency you feel, the sense that time matters, that choices matter, is not a bug in the system. It is part of what this phase of the universe is like. A rock does not worry about its future. A star does not regret its past. A conscious being can do both. The awareness that this will end sharpens experience. A sunset is beautiful partly because you cannot hold it. A life is precious partly because you cannot extend it indefinitely. Knowing that there is no escape also strips away some excuses. If this is the only universe and the only life you get, you cannot reasonably defer meaning to some later, better context. There is no real existence waiting after this as a safety net. Whatever kindness, curiosity, connection, or understanding will ever exist in your corner of reality has to exist while you are here to enact it. That does not make every moment sacred by decree, but it does make every moment an opportunity that will not come again. It can also soften certain kinds of guilt and anxiety. You're not failing a cosmic test. You're not being measured by an external system you might be thrown out of. You're a finite pattern trying to navigate a world that never promised to be fair or tailored to your comfort. You will make mistakes. You will hurt people. You will waste time. None of that is erased, but none of it condemns you to an eternity of suffering elsewhere. The consequences play out here, in you, in others, in the environment, and then they are part of the universe's ongoing indifferent story. This framing does not tell you how to grieve, how to face your own mortality, or how to handle the loss of people you love. Those are emotional tasks, not scientific ones. What it does offer is a simpler landscape. One universe, one life, no outside. Your death is a change of state within that universe, not a departure from it. Your fear is a feature of the conscious phase, not a sign that something has gone uniquely wrong. In that simpler landscape, hope changes too. It can no longer be about escape routes. It becomes about what can still happen here. Healing, understanding, connection, small improvements in the tiny region of spacetime where you have influence. The fact that the universe will not remember you in any personal way does not mean the people around you won't, or that their lives will not be shaped by what you do now. So the idea that you will never escape the universe reframes the fear of death rather than solving it. It takes away the fantasy of elsewhere and replaces it with a stark but honest picture. You begin, you exist for a while as a conscious pattern, you end, and all of it happens inside one unbroken reality that keeps going. The question that remains is not, what will become of me out there, but what will I do, knowing that everything that will ever happen to me happens in here? That question points directly at the final step in this journey. If you're not a guest in the universe, but a piece of it briefly awake, then your death is not a failure to get out, but a moment when that wakefulness fades. What does it mean then, to live and to die as the universe looking back at itself? At some point, after enough astronomy, enough physics, enough talk of entropy and information and horizons, a quieter shock begins to sink in. The real improbability is not that you cannot leave the universe. It is that you ever appeared inside it in the first place, that out of all the ways matter and energy could have been arranged, there was a stretch of time where they were arranged as you. For most of cosmic history, there were no questions. There was only unfolding, quarks and gluons in a newborn fireball, hydrogen clouds cooling and collapsing, stars forming, shining, exploding, planets accreting from dust and rock, chemistry bubbling in oceans and atmospheres, all of it driven by simple laws no more self-aware than falling rain. The universe did not care that it existed. It simply did. Then, on at least one small world, a particular chain of accidents and necessities produced something new. Molecules began to copy themselves. Those that copied better became more common. Over billions of years, blind selections sculpted cells, tissues, senses, nervous systems. At some point, there is no single moment to point to, clusters of neurons reached a level of complexity where the universe, in that region, could feel hunger and pain, attraction and fear. Later, curiosity, nostalgia, and existential dread. You are one of those clusters, running one of those patterns. You did not choose to exist. You did not tune the constants of nature. You did not set the initial conditions. You woke up in the middle of a process that had been going on for almost 14 billion years and discovered with some surprise that you could notice it. The odds against this, in any intuitive sense, are staggering. Not because the universe is tailored to you, there is no sign it is, but because the conditions required for beings like you to appear are narrow. Stars must form with the right mix of elements. Planets must exist in the right temperature range. Chemistry must stumble into self-replication. Evolution must, by countless tiny steps, build nervous systems complicated enough to model themselves. Even if life is common in the cosmos, the particular path that led to you is a single thread among an unthinkable number of possibilities. The universe could have been a featureless soup, expanding and cooling without ever making stars. It could have formed stars but no heavy elements. It could have made planets but never chemistry that can copy itself. It could have made life that never went beyond simple cells, or animals that never turned inward to ask questions. In almost every variation, there is no you to worry about escape, because there is no one to worry at all. Yet here you are, in one branch of one galaxy around one star on one planet, thinking about your own ending and the fate of everything. That fact is not a reward, or a gift, or a test. It is a brute fact of how this particular patch of the universe has unfolded. But just because it is unplanned does not make it any less astonishing. When you look at yourself through this lens, the impossibility of escaping the universe stops being the headline. Of course, you cannot escape. There is nowhere else to go. The laws that allowed you to exist are the same laws that keep you here. The deeper question becomes, what does it mean that for a finite time the universe configured itself into something that can even think about escape? It means that in your case, matter has learned to tell stories. Hydrogen and carbon and oxygen, arranged in the right way, can imagine futures that do not yet exist, replay pasts that no longer do, and assign meaning to patterns that would, to anything else, be just another arrangement. You are the universe adding commentary to itself. It means that you are capable of caring, not in some mystical sense, but as a real, emergent property. A brain like yours can value things. People, places, ideas, experiences. Those values shape your behavior, and your behavior nudges the state of the world. The atoms don't know they care. The pattern does. That capacity to care is as much a part of the universe as gravity or electromagnetism, just localized and temporary. It also means that your fear of death, your desire for escape, and your search for meaning are not errors. They are what this phase feels like from the inside. A star does not mourn its future collapse into a white dwarf. A black hole does not dread its evaporation. A conscious being does. That dread is not evidence that something has gone cosmically wrong. It is evidence that something has gone cosmically right, that the universe has, here and now, become aware enough to protest its own transience. When you consider all of that, the fact that you will never escape the universe starts to look less like a cage and more like a backdrop. You were always going to be here, if you were going to be anywhere, because here is all there is. The miracle is not that you are stuck. It is that the universe ever arranged itself into you at all, a configuration that can see its own constraints, feel their weight, and still find reasons to act, to love, to create inside them. And because this configuration is finite, there is a strange urgency built into it. You do not get to rerun this exact pattern. There will never be another moment that is precisely this one, with this history behind it and this future ahead. The universe may be indifferent, but you are not. That asymmetry is where meaning slips in, not as a cosmic decree, but as a local decision. So when you hear you will never escape the universe, you can hear underneath it a quieter statement. You belong to it completely. You have always belonged to it. You were never a misplaced fragment. You were a possibility encoded in its laws and initial conditions, realized once, now, as you. What you do with that realization, whether it terrifies you, comforts you, or motivates you, is itself part of the story. And that brings everything to the edge of the last step. If you're not a guest in the universe but a moment of it waking up, then your death is not eviction, but sleep. The question that remains is how to meet that sleep, knowing that you have never, for even an instant, been anywhere but home. At the beginning, the question sounded simple. What happens when you die, and do you ever escape the universe? By now, after stars and atoms, black holes and heat death, quantum fields and holograms, the answer is clear in one specific sense. No, you do not go anywhere outside the universe because there is no outside in the way the question assumes. There is only this, one reality with many phases and you as one of them. When your heart stops and your brain can no longer sustain the pattern that feels like you, your subjective experience ends. There is no evidence in any well-tested physics that a coherent conscious self continues elsewhere. Your atoms remain, your energy is redistributed. The information about your existence is scrambled but not erased. Your entire life, as a stretch of space-time and a set of correlations, remains part of the universe's structure. But the stream of awareness you call me does not pick up in another realm. You never escape the universe because you are never separate from it. From the first hydrogen atoms forged after the Big Bang, through the stars that cooked heavier elements, through the chemistry that built your body, every part of you has always been inside the same system. Your lungs are open to the atmosphere, your gut is open to the biosphere, your brain is shaped by other brains, your gravity tugs infinitesimally on distant galaxies. At no point were you a sealed object that could have been moved elsewhere. You have always been a way the universe behaves here. That can sound bleak if you grew up with stories about elsewhere, about souls departing or higher planes or cosmic exits. But it can also feel like an answer to a deeper fear you might not have fully named, the fear of being thrown away. In this picture, nothing is thrown away. Patterns end, pieces do not. The universe keeps all of its matter, all of its energy, and as far as current physics can tell, all of its information. Once you have existed, that fact is never undone. It just stops being important to anything that feels like you. So what does that leave you with, while you are still here? It leaves you with one life in one universe, with no dress rehearsal and no second stage. It leaves you with a body that is constantly exchanging matter with the world, a mind that is a temporary self-aware pattern running on that body, and a finite window during which you can think, choose, connect, and care. It leaves you with the knowledge that whatever meaning will ever exist for you has to be made inside this arrangement, not imported from outside it. It also leaves you with a kind of belonging that does not depend on comfort. You are not a mistake. You are not out of place. You are what happens when this universe, under these laws, in this corner of space-time, reaches a certain level of complexity. The same physics that will one day dissolve you is the physics that allowed you to arise at all. The indifference of the universe to your preferences is the flip side of its openness to your existence. Facing death with that in mind does not make it easy, but it changes the question. It is no longer, how do I get out of here? But, how do I live, knowing I am inseparable from here? You can respond with denial, with despair, with distraction. Or you can respond with something closer to awe, not because the universe is kind, but because you are here, briefly, as one of the ways it learns to see itself. One day, your pattern will fail. Your world line will have no more future segments where you are awake. The atoms will go on, the universe will go on. In a deep physical sense, you will never have left it, because there was never a moment when you were anywhere else. And that quietly is the point. You do not get to escape the universe. You get to be it, once, in this form, and then return, completely, to the everything you were made from.